So I'll start with what is network. So what is network? So guys, you can always put down your answers in the chat. So what is network? So like if two computers are connected, they are all, this is also a network, right? So computer A is connected to computer B. So they can share the things with each other. They can send files to each other. So this is a network also, right? And if multiple computers are connected, suppose four computers or four devices are connected with a device which is known as what? How to do? Yeah. So four devices are connected with a device that is known as switch. Okay. So this is also a network. When four computers or four devices are connected together, that is also a network, right? And when we talk about like, suppose I'm sitting in India right now, and you will be taking this session from US. Okay. So I'm in India right now, and you are in US. So so we are also connected, right? But how we are connected? We are connected with service provider network. Okay, so you have your own ISP. Suppose you have AT&T, and in India I'm using maybe Airtel or Geo or whatever, right? So all these ISPs are connected together with a cable, or you can say that a fiber cable, that is submarine cable. Submarine cable. Okay. Okay, so what is submarine cable? I'll show you all these things. Okay. So this is also a network. So means network can be like two computers are connected together, and and network can be like if four or five computers are connected. So computers, PCs, laptops, mobiles, you can say anything, any host. So we can say that host. So what is host? So host, basically any device which gets the IP address is known as host. So PC is host, laptop is host, server is host. So when we say host in networking, so host means the any device which gets the IP address, that is host. Okay. So PC, laptop, servers, all these machines are your host. Okay. So now, so got my point, right? So this is network. And what is networking then? So this is network. So what is networking? Right? So IT networking, or you can say the networking. So networking means when they are going to share the data. So suppose you are watching my screen right now. So we are sharing resources with each other. So sharing of data and resources is known as networking. Okay. So sharing of data and resources in a network is known as networking. Yeah. The basic I'm covering. Okay, so now in network we have like in industry we call this LAN and WAN. So don't just read the books with MAN, PAN, and there are a lot of other networks. So just simply learn these two terms, LAN and WAN. So what is LAN and WAN? So LAN is local area network. Okay, and what is WAN? That is wide area network. So these are only just the terms. Trust me. But when you will be in the industry, you will not be figure out this is WAN or LAN, what exactly. But yes, in a simple term, suppose uh, you have your own office, and let's say this office is in Mumbai. Okay, so this device, this icon is of a circle with this like four lines. So this is a representation of a router. Okay, so this is a representation of router. So why I'm adding a router here in Mumbai? Because maybe I have another router in Chennai. Okay. Okay, so why we have two routers? Because when we connect with the different networks, we need a device that is known as router. So what is router? So when you want to connect two different networks, so I'll write here router. So when you want to connect two or more networks, and which are different, right? So when you want to connect two or more different networks, okay, so different networks, then we use this router. So let me take an example. Suppose you are sitting at home, you have a broadband router right now, and router is connected with internet. Okay, so you have your own mobile phone, laptops, okay, which are connected with the router. Okay, so my these devices or these PCs are connected to internet. So internet is what? Internet is a network of networks. So what is internet? Because a lot many companies and users are connected, that is internet. So internet is nothing but network of networks, a very big network which is a combo of small networks, big networks. So you can simply say that internet is network of networks, right? Yes, it's an interconnection of network, correct? Right. So this device router is helping you out to connect outside your network. So this is the role of router. When you connect with a different network, this is the reason we all have routers at home when we get the broadband connection or any type of connection. Got it? So this is the reason when you have your branch in Mumbai and you have another branch office in Chennai, so if you want to connect both the locations, so you need a hardware device that is known as router. Okay, got it? So router is what? When two or more different networks are connected together, they actually need a device that is router. Okay, got it? So below this network, below this router, okay, so we have a device that is, you can say that simply, that is a device which is a switch. Okay, so has a lot of ports, like 4 ports, 8 ports. So it has a ports where we can connect our computers, servers, printers, or any type of network device. And this switch is actually connected with your router. Okay, so this area, you can say that this is a LAN network, right? And Chennai also have same type of terminology, that we have a switch, all my computer servers are connected together, and that is also a local area network. And this, we can say that this is a wide area network. And now WAN, so this wide area network doesn't mean like we are connecting two locations only, that is WAN. So WAN can be of two types, that is private and one is public. Okay, so public means internet and private means your private connection. So when you are paying, see, it's a very simple thing, just understand. So when you are not getting, or if you don't want to pay a lot, you can just use internet connections. Suppose Mumbai device, just hold on. Yeah. So Mumbai device is connected with internet and Chennai is also connected with the internet. Right. So now with the help of internet, you are actually connecting your Mumbai and Chennai, that we can say that this is a VPN. Okay, so when you want to connect Mumbai and Chennai location with internet, because in Mumbai we also have internet, in Chennai we also have internet, right? So when you want to connect to your branch offices headquarters, at that time we can say that we need to create a VPN connection between Mumbai and Chennai, that is your public WAN. So this type of network is known as public WAN, when you are actually using public resources and connecting your locations. Got it? Say yes in the chat. Yeah, I'll explain what is a switch. Don't worry. Okay, good. Yes. Okay, so when we are going to connect with the help of internet, that is known as public WAN. And when we have enough money that we want secure connection, we can use a dedicated line that is known as private WAN. But yes, we don't have enough funds to invest a cable between Mumbai and Chennai. So who is going to make or create a connection for you? ISP. So in both the networks, in private WAN, your ISP will be same for on both the ends. Like in Mumbai, also you are using Airtel, and in Chennai also you have to use Airtel. Then only you Airtel can create a virtual connection or hardware connection, lease line. There are lot many type of ISP connections available, right? Like MPLS, L2 VPN, L3 VPN. There are a lot of other connectivities that is too advanced right now for you. So just understand one thing, like in WAN we have two type of connections, private and public. So when we connect all our offices with internet, okay, so that is public WAN. And when we connect all our offices with the dedicated line with a high cost cable or leased line, you can say that leased line. Okay, so that type of connection you can say that private. So private is costly and secure, but so it's a secure connection because nobody is in between the connections. But in public WAN, it's internet, it's not costly, it's a cheap connection, but yet it's not secure. So this is the reason we have to use advanced technologies like VPN, IPsec, or other type of things. So that I'll discuss. Okay, so that is the difference between local area network and wide area network. So local means the network which is behind your router, or you can say that downstream, uh, like all your switches, routers, and all. So this is the LAN network. When you are going from outside your network, that is WAN, wide area network. So you can simply say that. So this is my wide area network. Okay. Yeah. So let's move on. So I'll explain what is a switch. Okay. See, so switch is a device which is used to connect two or more hosts or two or more computers. So what you will do when you have two or more computers, like let's take an example. Suppose we are four guys and we want to play a LAN game. Okay, so we want to play a LAN game like Counter Strike, Call of Duty, and anything, right? We want to play together. What exactly we will do? So either we can create we can connect with the Wi-Fi or something, but or simply we can buy a switch from market which is hardly 10 to $15, right? And we will connect all our devices with this device. This is a switch. But we in market, when we buy switches from Amazon or from any website, it starts from $10. And like we have a very big companies like Cisco, Juniper, HP, Aruba, and lot many big companies. They have $2,000 switches. They have $20,000 switches. But what is the difference between this $10 and $2,000? Basically features. Features. So in a normal $10 switch, when this device uh, wants to communicate with B, the information will pass on to D also, C also. So this happens with the local switches, which are known as unmanageable switches. So unmanageable switches are nothing, just a extension to the devices. Like suppose you have a power surge, right, at your home or at your office, or extension board, what we call. So you have a one power socket. So what you will do when you want to connect multiple devices, you will order a power surge, right? Or a power extension board where you get multiple ports, and you can put your charger, laptop charger, and other things, right? So the same it this unmanageable switch is like, this is just an extension so that you can connect multiple devices. But when we talk about manageable devices, manageable switches, so they have a lot of functionalities, like VLAN is a concept which comes under manageable switch. So all your industry companies or big firms actually uses manageable switches, so that it we can create a lot many or we can use a good features in these manageable switches. But in unmanageable switches we hardly get any feature. Okay. Yes, you can say that it works like a hub, right? But it's not a hub right now, because hub is a obsolete technology. Nobody uses hub right now. Guys, can you please stop your video? Okay. Okay. So switch is nothing. When we want to connect devices in a company, we use actually manageable switches. And when we just want to play games or just want to use at our home offices or a very small offices, we can use unmanageable switches. So now in switches, we have this term L2 and L3. So what is this L2 and L3 switch? Okay. So L2, L3 switch I'll explain later, because before knowing this, you should know about the OSI model. What is the example of unmanageable switch? I'll show you something. Just hold on. Hmm. Okay, so I'll show you. See, this is an unmanageable switches. So you can see it hardly costs $10, 15, 20, $17 device, which will help you to connect 4 to 5 machines. So you can see, so it's a 17.99 $18 device, which will help you to connect at least approx 4 to 5 devices. So you can see 5 port. So it means you can plug almost 5 devices in this device, and this is unmanaged. You can see here, unmanaged. So in industry, you can have around 24 port, 8 port, or 48 port also. So you can able to connect 48 devices. So that is unmanageable device. That is very like you can say that cheap or like cost effective. But from industry point of view, this is not acceptable because it doesn't have too many things. Okay. Yeah, but you can see here is managed, but somehow it's a smart managed or partially managed. So it is giving you option of VLAN, but if you go and buy the Cisco switches, which are or HP switches, so they are very costly. So these even Cisco makes very small devices nowadays. Okay, but this is hardly at $60. But when you go into the industry side, it will cost more, or maybe $1,000, or maybe you can see this. So I'll show you one device that is 3850. So that model is 3850. Okay. So Cisco has a device that is also a switch that will cost around 3000 plus, or maybe and maybe this is a new, or you can see the actual price is $14,000. Maybe this is the old one or refurbished one. Okay. I'm audible, guys? Okay, great. Thank you. Okay, so this is the difference between managed and unmanageable. Okay, so I'm giving you some real examples by showing some images and with Amazon. So what's the difference actually? So unmanageable is like very basic functionality just to get the work done. But in manageable switch, we get VLAN features and lot other things. So this is the difference between unmanageable and manageable. Because people actually ask me when they do um, uh, what exactly they ask, sir, what's the difference between this $10 or $20 switch and with $2,000 devices, because they have more functionalities. They have, and what type of functionalities that you will discuss, that will be discussed later on. Yes, so it goes with the router also. So if you have let me show you. Yeah, so now let me take a snapshot so that I, okay, so now router. So router is also like you can say that it's a manageable or unmanageable, but it's better to call this uh, when we have this device at our home. So we actually think that this is a router. Suppose you have a broadband connection, but this is not a router. This is actually a device which is a combo of a router, modem, these type of technologies, and this is what we call ADSL device or DSL device. Okay, so what is ADSL? That is asymmetric digital subscriber line. Suppose you got a connection from AT&T, or maybe you got a connection from Airtel in India. Okay, any from any ISP. So the type of device you are looking at right now, maybe that device is not a router. So that is a ADSL because it has a functionality of modem. So why we use modem, by the way? So let me explain you what is modem. So modem is actually doing modulation. So what is modulation? And modem also does the demodulation. And what is this demodulation? So when we get any type of signals, they are coming in the form of analog signals, right? So when the signals are coming to your device and your computer understand which signals, digital signals, right? So we can't send analog signals directly to the system, to the PC. So this is the reason we have, or ISP put down one device, that is ADSL. So this device is actually converting your analog signals into digital signals and sending those signals in the form of 0 and 1, and computer understand those signals, and the same way it is giving back digital signals, and ADSL is converting these digital signals again back to the analog signal. So this is modem, and this modem is actually integrated into this device ADSL. And now ADSL has one another functionality, router, because this device is actually created for multi-purpose. Router, modem, it has a 3 4 ports outside also, like it has a small switch inside also. And this is a very cheap device which is used by ISP to provide the internet connectivity. Yeah, it goes with the fiber also. Your fiber modems actually converting your light signals, because when you have a fiber or fiber type of modem, the signals are coming in the form of light, right? So that is optical transmission. So when we get any type of communication with in the form of signals, that we call this optical, but your computer does not understand these type of things. So we have to convert this into digital signals or electrical signals. So this is what fiber modem does. So fiber modem is converting your light signals into electrical signals. Got it? Yeah. So Himanshu has a question. Sir, I have a Wi-Fi router. These are not Wi-Fi routers basically. So if ISP has given you something, I'll show you with the example again. Okay, just hold on. Mm, yeah. So again, see, when we buy ADSL, so this type of device is like a router, but it has ADSL functionality also. Like you can see this modem. So this is a Motorola device or with Wi-Fi. Everything is inside, and it has a lot. See, you can see the ports. So it is a switch also, because it has around 4 or 5 ports so that you can connect to your devices. And it has a DSL cable also. This DSL is when we have phone connectivity, like from any of the service provider. This all that cable is actually giving you analog signal, and this port is actually converting your analog signals to digital. Okay, so this is ADSL device. Okay, ADSL, DSL. So this is actually a combo of router, modem, and somehow switch also. Okay, and when we get this Wi-Fi router, okay, so these type of devices like Wi-Fi router, and let's check the ports, guys. So you can see here we have only internet cable, but this type of port is not like DSL. So it means when you are putting any connectivity here or any type of connection, so ISP should give an Ethernet link to you. Then only you can use this type of device. It means, uh, let me show you. Okay. So what I was trying to say. So like, okay. So ISP. What is ISP, by the way? Internet Service Provider. Okay. So ISP is giving you connection, and you have this device which we call this ADSL. Okay. It has a Wi-Fi, but it has a limited range. It only goes up to maybe 100 square feet area. But you have a big home, big house, and you want to send these signals to another uh, part of the room. So what you will do, you will put a Wi-Fi router here, which we have seen right now. So we can just put down one cable, and we can place a Wi-Fi router here to extend the range, basically. So ADSL is required when you are getting the connectivity in the form of either this type of cable. We used to use this PSTN cable, like public switch telephone network cable, either in the form of fiber. So when you are going to get the fiber connectivity, we are going to use fiber modems. Okay, and uh, so ADSL, fiber, sometimes ISP gives direct Ethernet connectivity also, or what we call this copper cable. Sometimes I have seen this, but it's not common. So this is PSTN is common, and fiber nowadays is common. Yeah, thanks, Nikhil. Yeah, fiber modems I explained, like when any device or any ISP is sending, because light has more speed, right? So when we are sending data with the in the form of light, right, this fiber modem is actually converting your light signals into electrical signals, because your computer still don't understand what we call this light optical signals, because your computers does not have that type of chips, those who understand light signals. But when you go into this corporate world, your router actually gets fiber cable directly into the port. Means we can place fiber cables inside our routers. So how? Why we can't put fiber cables in computers? because the router, uh, these type of routers or any high-end devices or nowadays servers also, so they have a small chip that is known as SFP. So this chip is known as small form pluggable adapter. So this chip is like a small modem which is helping you out to convert your light signals into electrical signals to the router. Are you getting now? So this works like a small modem which actually converting your optical signals into electrical signal. This is the work done by SFP. So this is the reason we have SFP type of chips inside the router. If you have not seen it, ignore right now. We will see later on. Okay. But high-end devices can, like in a server, in a routers, we can place fiber cables directly because of this small chips, SFP. Himanshu, that you have to figure out. ADSL, you are getting a ADSL, you have four ports outside ADSL, and you can just connect a Ethernet cable to your Wi-Fi router and put that device into bridge mode or any type of mode. It will show you the all the functionality Wi-Fi router. Okay, clear. Just say yes. SFP is a small form pluggable adapter. I'll show you what is SFP. Again, I'll give you real examples also. Okay, so I'll show you what is SFP. SFP. Okay, so SFP is actually a small chip, or you can say that it's a small part. Okay, so this part is actually we are putting this part inside the servers, routers, so that it can convert optical signals into electrical signals, because we can't put optical signals directly into the devices. So you can see here all the Cisco devices or all other company devices are using these type of ports. We are not putting directly fiber cable into the device, because we are putting this SFP first and then we are putting or adding the cable. Clear? What is the SFP plus? SFP plus means 10 GB. SFP is 1 GB. SFP plus is 10 GB. Okay. Himanshu, that is a different concept. Yeah. So I'm not going inside very advanced right now. So because this is a network fundamental class. Okay. Yeah. So I have explained you what is a router, switch also. Okay. Uh, I'll show you something interesting. So that I always show to my students. So just hold on. No, Avinash. So Avinash is asking something that it has 250 computers, like 250 computers. Okay. So all these computers are actually, suppose these are 250 pieces. Okay. So all these PCs have one chip that is known as, all machines, all laptops have one card that is known as NIC card. So that is network interface card. So you can check your laptop right now. You may be having some port where we can put down the cable, or maybe you have wireless, right? Why maybe you should have this wireless card. So all these chips are known as NIC. So either we have wired NIC where we can put down our cable, and we have wireless NIC. So what is this NIC? NIC is a chip or any type of part which is actually helping you to connect your computers with the network. Okay, so you are adding the network cables into the computers, and where we are adding these cables in a small like this chip is nowadays integrated in the motherboard, so we don't have to add this. But a few years back we need to buy a separate card to install in the PCs, but nowadays it's pre-installed into the motherboard. Okay. Yeah. NIC card is basically your Ethernet port. Yes, when we say we have Ethernet port in our laptop, that actually means it's a NIC. And do you know that your computer does not have any MAC address? Your NIC chips have. It means if my laptop has wired NIC, means and wireless NIC, and a Bluetooth adapter, Bluetooth NIC, Bluetooth means also NIC. So it means if I have three things in my laptop, it means how many MAC address we will have? Three MAC address. Okay. Because this MAC address, when we say MAC address, so this is not an address which we are giving to any computer or machine. This is a hardware address which is actually address of these chips. Either it is a Bluetooth, wireless or wired. Okay. So if somebody is asking you how many MAC address you have in your laptop, just count the NIC. Okay, so NIC you can count, you can check with the help of which command? ipconfig. Okay, so I'm using MacBook here, so I can. So if you are using Windows, you can type ipconfig right now, and you can see all the details or your yes, your NIC. So I'm in Linux and in MacBook, we have if config. Okay, so in if config, so you can see a lot many ports here because some are virtual ports. Okay, virtual means that is created just for the virtual purpose like VMware and all. Okay, so you can see here EN0. So my computer is getting this IP address right now 192.168.1.3. Okay, so you can use ipconfig. Okay. Yeah, I'll explain MAC address, don't worry. Okay. Avinash, it's same, just the name. Okay. Yeah. So how many candidates we got? 120. Okay. So let's okay. Yeah, so I was discussing the question. So we have around 250 computers, remember? Yeah. So when we have all these devices are connected with the device we call this switch. Okay. All the cables are going inside this device. This is switch. Right. So these suppose these type of NIC have a speed. Nowadays we got 1 Gbps, but few old laptops have 100 Mbps. So suppose all the ports. So do you know what is kbps, mbps, and all these things? So just a quick overview. So we have 0 and 1. These are known as bits. Okay. So when we have 8 0 1s, when we count 8 0 or 1s, either it would be 0 or 1, that 8 bits are known as 1 byte. So like 0 1 0 1 1 1 0 0. So what is this? This is 1 byte. Okay. So when we have 8 0 and 1s, computer understand this 1 byte. Okay. And when we have 1024 bytes, when we have combo of, this is a group which is byte, when we have 1024 similar 01s, that is known as 1 kilobyte. Okay. Obviously, then you know KB, and when we have 1024 KB, we say this, what we call this, 1 MB, megabyte. And then we have gigabyte, terabyte, petabyte, hexabyte, exabyte, zettabyte, a lot of many bytes. Okay, so you can check this on Google, but yes, you understand this. Bits, 8 bits is 1 byte, and 102. See, I was taking one interview few years back, and just I asked one person, what is 1 byte? So even that person can't able to give that. So he was saying 8 bits. So I was just asking, what is 8 bits? So that was the actually answer. 0 ones are actually bits, right? So 0 and 1 are bits. So it happens sometimes, you know, but you can't. In interviews, you got blank. Okay. So now if all my devices are 100 Mbps, right? So how much throughput they will get? What is throughput? Means how much data they can send or receive, maximum 100 Mbps. If my computer has 100 Mbps, what is the maximum throughput? Throughput means how much data I can send or receive, that is throughput. So how much data this device maximum send or receive? 100 Mbps, right? That is the same example. Like we are we have a pipe from where we are transferring water or something, right? So we can, when the pipe is broad, then we can send or transfer a lot of water. But when the pipe is smaller, we can share small amount of water, right? So this is what I'm trying to explain. This all your computers are like 100 Mbps. They can only get maximum 100 Mbps, and you got an internet connection of 1 Gbps. Tell me how much maximum speed these computers will get. Tell me. You have 1 Gbps internet connection, but your computers have 100 Mbps. So what would be the maximum speed you will get? Yes, correct. 100 Mbps, right? So that is exactly throughput means. And let's take another example. Let's take another example. When you have 1 Gbps, all your ports have 1 Gbps, but they are using 100 Mbps connection. So what would be the maximum speed these devices will get? Again 100, right? Because you are going to internet, but when they are sending data to each other, they are sending data to each other, or they are sharing data between them, how much data or how much throughput they will get? Yes, 1 Gbps. Correct, correct. Very good. Cool. Clear? Okay, good. Okay, so explain again. Okay, so explain again. Okay, don't worry. So I was saying, so this is my computer. Okay. Okay, so I'm getting internet connection of 1 Gbps, but I have a chip in my computer which is only supports 100 Mbps. That is, so 100 Mbps, sometimes we call this 100 Mbps fast Ethernet. Okay, so when we use 1 GB or 1 GB connection. So we call this 1 gigabyte or giga ethernet. Okay. And when we have 10 Mbps speed, which is very obsolete, but we call this ethernet. Okay, ethernet. So I'm asking, you have an internet connection of 1 Gbps. You have a device here which is giving you whole 1 Gbps, but your computer supports 100 only. Okay, so you can't have speed more than 100 Mbps. So I'll give you another example. So all devices should have good speed, right? Suppose you have 1 Gbps, okay, and your computer has 1 Gbps, but you have a device which is only supports 300 Mbps. So tell me how much speed you will get. Maximum 300, right? Because between the transmission, if any device have low bandwidth, it means you are going to get the same bandwidth. Okay. So I'll show you one trick from ISP side. Okay. So I'll show you one thing. So just let me show you one thing. Suppose you have very good laptop, right? MacBook, and you have 1 Gbps port. You got an internet connection also. Suppose 100 Mbps. Okay. You got an internet connection of 100 Mbps. Okay. So you are paying for 100 Mbps plan. Suppose you are paying $50 or approximately 2000 Indian currency. So you are paying for this internet connection, but you think that you are getting 100 Mbps connectivity. Okay. And when you are watching a video from YouTube, but you are getting a delay, means it keeps on buffering, and you always complain to this local ISP, man, you have given me 100 Mbps, but I'm not able to watch this YouTube in 720 pixels or 1080. Why? Because maybe this local ISP giving you 100 Mbps link here, but maybe they have a 100 MB or maybe low bandwidth link over the internet, because they are also taking connection from somewhere. So this is the trick actually played by local ISP, right? So they say 1 Gbps, 100 Mbps, but when you actually do the speed test, they go to their server only. um, I hope I'm trying to explain this, so I'll show you exactly. Okay, I'm going with speed test. Okay, so I'm checking speed test. So by the way, I'm in North India right now in Chandigarh. Okay, so I'll check. This is a small ISP I'm using, fast way. Okay, so let me check the speed. Go. So it's giving me 70, 80. Even I'm teaching right now with Zoom. So this is the reason it's giving me 80, 90 and all. It means from my ISP is giving me around 90 Mbps and upload speed also 90 to 100 Mbps. Right? Are you getting now? So you always go and check, okay, and they show you the speed test. But exactly it doesn't mean you are actually getting 100 Mbps over the internet. So this is just a marketing gimmick by ISPs. I'm actually opening their secrets. Okay, no issues. So 100 Mbps, here we are getting 90, but again I'm going to speed test, but I'm going to choose another server. Maybe it's in Bangalore or maybe somewhere, or maybe let's check in New York. Let's test any server in New York. So let's test how much speed actually. So you can just check the speed outside India and you will be actually getting that speed only. So you can't go more than that. So let's see. It's going good. Might be my ISP is good, right? But see, if New York is giving me 70, it means my ISP is good. This is how you check your ISP. So just check with another country ISP or any location, and you will find this actually gives me, yes. So mine is better because I have around 3 connections at my home, and I'm using this one because this is the best one. Okay. Now you got the point what I was trying to say. If you are getting low speed over the different servers, it means the bandwidth is choking somewhere. Okay. Might be ISP have low bandwidth plan. So this is you guys need to check. Okay. Cool. Okay, guys, let's take a 5 to so these sessions are of 2 hours. Okay, 9 p.m. to 11 p.m. Okay, so I don't think you will mind if I'm going to take 5 to 10 minutes break because I have not done my dinner yet. So I'm going to take 10 minutes break. Okay, so we will meet at 10:12. Okay, yeah, yeah. So have your dinner and come back in 10 minutes. So I'm just going to pause this record. Okay, great. And I'll explain you how to access the lab also. Okay. Okay, so what exactly we are going to do? We are going to connect two machines and we will see how they are going to share files with each other. Okay. So we are going we are going with the first practical. Okay, in the first practical or first lab, what we are going to do. So like my two computers will be connecting with a cable and I'm going to assign IP address here and I'm going to assign one IP address here. And before assigning the IP address, so I'm going to explain you one thing that is IP address classes. So just remember one thing. We have three classes, class A, B, C. D, E we will discuss. So when any IP address start from 1 or between 1 to 126, you need to match the first part. That is first is network part. I'll explain. So if two computers are connected together, they have IP 1.1.1.1 and this computer is having 1.1.1.5. So in class A, any IP address start from between 1 to 126. We just need to check the first part. So tell me they are matching or not? Yes? Yes. So it means they will communicate with each other. What if I'm going to give 1.1.1.1 and here 2.1.1.1? So our is the first octet or first part is matching? No, right? So they will not communicate. They are not going to communicate with each other because our first network part in class A between 1 to 126 by default is this. We can change these things. That terminology is known as subnetting. Okay, that we will discuss later on. So in B, when the IP address is between 128 to 191, so we need to check how many parts. We need to match two parts, guys, two parts only. It means when we have IP 150.1.1.1 and here we have 150.2.1.1 or 2.7. So tell me, are they going to communicate with each other? Yes, routing is a different. I'm just asking about two computers first. See, in class B, need to match two things. So just check if two things or first two parts are matching. No, big no. They will not communicate. They are not going to communicate with each other. Why? Because my first two octets are not matching. My network bits are not matching. It means they are not in my network. This is the power of network bits. In class C, we have 192 to 223. So that is 3 network part. It means we need to match 3 portion. So suppose I got 192.168.1.1, which is very common IP, 192.168.1.5. This is class C, where we are going to match 3 network bits. So tell me if they are going to communicate. Yes. And what we will do to communicate in between these ones? So what we are going to do, either we will make this 2, or either we will make both 150.1, right? Then they are able to communicate with each other. So this 127, which is not here, that is for loopback testing or loopback IPs. That is for self-owned IPs or local host. It means all your computers, when Windows starts, right, it appears a logo, all the services are in background, or all the services inside your machine, because your laptop machine itself is server for your machine, because you are getting all the images, all icons of the files. So that is a self-host IP or self-hosted IP addresses. That means these are your IPs. Okay, so means your internal IPs, which are not accessible or accessible from outside. Like it's a soul, you can say that, right? We can't transfer until unless you have black magic tricks. Okay, bad joke. Let's go with the lab. So labs, I'll explain later on. Just first do the lab first. Okay, to access the labs, we are going to use racks.nwkings.com. Here is the trick. I'm going to use one port number 8081. I think this is the 8086, sorry. Okay, and I'm going to use HTTPS here. Okay. So you'll be getting an email very soon to access the server. So we have installed Eve engine on top of our servers so that you can access the lab. Okay, so I have already made a lab here, 2PC. When you are going to log in, so you are going to get this lab, first lab here. Okay, so open it. You don't have to do anything, just these two PCs are my two window machines. Looks good? Or should I change the icons? Okay, it's good. So now I'm going to click on PC1 and I'm going to start this. Start. And I'm going to click on another PC, start. Okay. And just click on the PC1, and I'm here starting Windows 7, and in another PC also, PC2. So my two PCs are opened here. Cool, right? So the password is test123. Okay. T in uppercase. Test123. Remember it. When you are going to do the lab, it will help you. Okay, so my second PC is here. I'm going to log in test123. So my two PCs are here. Yes, it's fast, obviously. So how we are going to give IP address? So in Windows, I'm going to give you one shortcut, that is ncpa.cpl. You can write down this shortcut, ncpa.cpl. Okay, ncpa.cpl, enter it, and we are connected with this local area connection, means the port. So right click on this and properties, and here you can see Internet Protocol version 4. We are using version 4 right now. Okay, and click on properties, and here we are going to assign the IP. So this is the option here, obtain an IP address automatically. It means when you connect with Wi-Fi or any type of router or any device, it actually gives you IP address automatically. That is DHCP. So we will discuss DHCP later on, but here we are going to assign the IP. So I'm going to use class A1 1 1 1. Okay, and here we got by default automatically subnet mask. This 255, it means just need to match the first part. Okay, when we have 1255 here, it means we need to just check the first part. So in first PC, I have given 1.1.1.1. Okay, close. And let's check the IP address is configured or not. Status and details. Here we can see DHCP is enabled. No, because we have configured the IP address manually. So you can see here 1.1.1.1. Okay. So this is my first PC IP address 1.1.1.1. Close it. And in another PC, tell me which IP address should I use? Can I assign 2.1.1.5? Okay. So in the second system, I'm going to give properties, and inside the properties, I'm going to give here. I'm going to use 1, 1, 1. Let's take 100, or let's make it simple, 1112. Okay, again 255. It means my first computer and the second computer is having 255 here. It means I'm going to check the first portion. So if both the portion are same, it means both my PCs are in same network. Kevin, I'll explain IPv6 later on. It's little advanced, right? So first go with the IPv4, and this is how exactly we train. The difference between IPv4 and IPv6 is IPv4 is 32-bit and IPv6 is 128-bit. Means it's a combination of 128.0.1. It's a big address. We can assign a lot many IP addresses in IPv6. But in IPv4 we have limited range. So IPv4 is now almost collapse, or what we call that, or almost utilized. So this is the reason we have IPv6 now. Ashish, I'll explain. So so both the PCs, just see the practical guys first, okay? So might be you will learn something. Maybe it's very basic, but obviously it's a fundamental class, right? Hmm. So I'm going to show you something. So I'm in C directory. Let me go inside C. So I'm in C drive right now. So you can see this is my C drive, right? Right. So I'm going to create a one file here, or no need to create here. I'll show you something. So there is a command called ipconfig where you can see all your IP address. But I want to just get all this output in one file. So I'm in C drive. I'm just using this symbol and I'm putting this into one.txt, or this any name, suppose atul.txt. So in C drive, let's see if there is a file. Yes, we can see here atul.txt, and let's open it, and we got all the details. Even Windows sometimes behaves like Linux, right? So my computer is 1.1.1.1. Okay, and here you can see all Ethernet adapter and all. Okay, great. Okay, so let's check how to test if my another PC is connected to PC1. So how we are going to identify PC1 is connected to PC2 now? So there is a tool called ping. So ping stands for packet internet gropper, or okay. So this ping is a tool to test the connectivity between two devices or either hundred of devices also. So 1.1.1.2, we need to send this ping request. So you can see we are getting four replies. It means we have sent four packets. We got four replies. It means 0% loss. It means we are connected with this device. This is how we come to know these two devices are connected now. So what is TTL and time and all? I'll explain. So first of all, I'm by default I'm sending 32 bytes of packet. So ping is a packet. Okay. So I'm sending four packets and I'm getting four packets reply. It means so my two PC are connected. I'm sending four ping request. This is known as echo request. We call this echo request. Okay. And how computer understand this is a echo request? There is a code in it. And that code is basically 8. So this is a type code. So how my computer understand it's a request? Because when we send this echo request, echo is a type of message we are sending from PC A to PC B with a code that is echo request type code 8. That means it's a request and B is going to reply with all four replies here. So that is echo reply. For every request, we are going to receive one reply. It means we are sending four packets. It means we are going to get back four replies. And the echo reply code is 0. So that is the type code of echo reply. So this is how your computer understand when they are getting, because computer is getting 0 1, all the data in the form of 0 1. So how it is getting its echo reply or echo request? Because when we are going to write this 8 into this binary form, like kind of this. So when these type of 0 1s are coming from another device, it means we are getting a request and we need to send a reply back with all zeros. Okay. So if it's getting more complex, you can just simply understand it's a ping packet. We are sending request and we are getting reply back. And this is a tool to check the connectivity between two devices. So by default, we are sending what type of size? By default, when we are sending data, we are sending 32 bytes of packet. Okay. Yes, ICMP. Yeah. And in how much time we are getting reply back? In 2 millisecond, 1 millisecond. This time represents how much time my computer is sending data to another device, and device is sending reply, and this reply is coming in 2 millisecond. Second reply I got in 1 millisecond. Okay, third reply I'm getting in 2 milliseconds. So it varies, right? Sometimes it 2 millisecond, 3 millisecond. It depends on the location also. If you are pinging google.com, obviously you are going to get more time because Google servers are at different location. We call this latency. We call this uh, time also. You can say that delay. You can say that in network language. Delay, latency, time. All these are common or same thing. So what is TTL over here? That is time to live. Time to live. Suppose we are sending a ping to any device, but it's not actually present in my network. Suppose you are sending request from PC A to any device which is not in network. Okay, over the internet, it actually over the internet it is very important. When you are pinging google.com, but mistakenly you are pinging some another IP which is not over that IP is not available in the internet. So actually what happens, your routers, if you are sending ping request, your router is going to decrement this value with 1. Suppose you are sending request with 128, the first router will make it 127. The request is going with another router 126, 125. So if location is not identified, if location is not in my network or anywhere in the network, that packet will be discarded or dropped when the TTL value will be 0. So TTL is just like expiry date. Okay. So if I'm going to send a limit with 128, it means if we don't get this IP address within the 128 routers, I'm going to drop this packet. Got it? Why we have this TTL value? Because if we don't have TTL, the packet will keep revolving in our network and it will create internet loops. This is the power of TTL value. If we don't have anything in internet, it is going to discard it or drop after roaming to 128 routers. Yeah. Okay, cool. Are you getting these things? Okay, cool. Okay, it means TTL value is a like expiry date. If we don't get in 128 routers, I'm going to drop this packet. So that is TTL value. Okay. So my both PCs are connected with each other. Latency means a delay. Okay, if you are pinging from India to USA, definitely it is going to take time. That is latency. 0% loss doesn't mean you will have drops when you have high latency. It means yes, when the packet is coming from very long distance, sometimes packet drops and it will show you lost here. Okay, so now what I'm going to do, I'm going to share one folder in PC1 and let's see if PC2 can access it. Okay, so this is the first thing we are doing. See, when two computers are connected together, that is a network, right? I explained you. I have explained you. This is somebody is asking what ping actually command do. Ping is actually to test that another devices is connected to me or not. If I'm getting reply from another computer, it means both the devices are connected to each other and they can share files now. So let me share one file in PC1. I'm going to create one folder. Okay. Suppose I'm share. Okay. So let's make a folder Kevin here. Okay. So I'm adding this file in Kevin. So you can see, and let me just copy paste multiple times. So this folder has multiple files. Okay. So I'm going to share this folder, share with specific people, and I'm going to add everyone. And I'm going to add, okay, just click here, everyone, add, share, and share it. So now this Kevin folder is shared. How to access from another computer now? It's very simple. Just type here double slash and I'm going to type the IP address of first device. Boom. We got the folder, right? So you can see 1.1 in my network has shared the Kevin folder and I'm going to copy this or we can save. See in C drive we don't have folder and I'm going to paste here. So this is how we exactly transfer the files from one computer to another computer. Got it? Sometimes what happens, like you need to check your properties also, like advanced sharing settings. Sometimes your turn network discovery on file sharing, these are off. So you need to enable these ones. Then only you can access the folder. If you are not able to access from your real devices, sometimes like firewall is blocking or something is happening, you need to figure out. Okay. Yeah, obviously. So sometimes you need to disable this Windows firewall. Sometimes it is restricting you to share. So I have already disabled it. Okay. So this is how you are going to do the first lab. So this is for PC1, and let me show you few other things. Okay. So there is a So when we want to get the MAC address of this device, there is a command called get MAC-v. So if you want to see all your MAC address, there is a command get MAC-v. There is a command also ipconfig/all. But if you want to see all your network adapters MAC address, so this is the physical MAC address. You can see here 50.0000. So this is the MAC address. And there is another thing like ipconfig/all. So it will also display you the MAC address. So you can see here I'm using this technology Intel MT network. So this is my MAC address 50.001.0.0.0. And if you want to see in a very simple way, so just again go to that ncpa.cpl, and I'm going to click over here status and details, and here also you can see your physical MAC address. Okay, cool. So now your homework would be like you can check with class B, class C. Okay. Yeah, yeah. Okay. So I'll show you something today. So what is IP address basically? So IP address is of two types. One is IPv4, and when we have IPv6. So this is 32-bit IP address. It means it's a combo of 32 zero ones and it's a combo of 128 bits. You remember bits, right? So 0 and 1 is bits. So IPv4 is in the form of four groups. Four groups. Okay, and that is into decimal format. Like IP address is 200.1.1.1. This is a decimal format. When we see IP version 4, it represents into the decimal format. And in IPv6, we have a groups, eight groups. And here, like group is known as octet, and each group is of 8 bit. All groups are of 8 bit, and here each group is of 16 bit. So 16 into 8 is 128, right? So 16-bit group, and here we have 8-bit group and four groups. So 4 into 8 is 32. So if you plus all 8 bits, 8, 8, 8, 8, you are getting 32 bits. And here we have 16 groups and 8 groups. It means 128 bit. Okay. And here the IP address looks like this: 2001, 1234, 0000, kind of 000. Okay, it's actually big address. So I'm trying to just 3456. Okay, this type of address, very big address. You can see it's very short and easy to remember. Here it's complex, but yes, there is a way to shorter this address also. Okay, so we can place double colons instead of zeros. Okay, so we will discuss this later on. Okay, but IPv6 looks like this address, and you can see some CAFE, ABCD and all these terms. This is known as hexadecimal. Why we use IPv6? Because we have a shortage of IPv4. Almost all IPv4 is used now. So this is the reason IPv6 is commonly seen nowadays. Okay. So to start learning IP address subnetting, you need to understand the basic concepts, that is like decimal to binary, binary to decimal, all other things. So just a quick intro, I'll give you overview about what is decimal to binary and why it's important. I'll show you. Trust me, if you already know this thing, but still you are going to learn something new today. Suppose we have a IP address 192.168.1.1. So this is a decimal format. Your computer does not understand decimal format. Your computer understand binary. So these things we are learning from our school days, that computer understand binary language, machine language, right? So how computer is going to understand this IP address? We also need to understand that thing. So IP address, I told you this is of 32-bit and each group is of 8-bit. Every group is of 8-bit. And how we represent this? Because 0 and 1, how many values are the, so 0 1, it means this is a 2, right? It's two values. So this is the reason we always take the combo of 2. So we can take to the power of to represent 8 bits. How we are going to represent it? We start with the power of 2, from right to left, to the power of 0, to the power of 1, to the power of 2, to the power of 3, 4, 5, to the power of 6, to the power of 7. So if you know these things, it's good. So to the power of 0 is 1, to the power of 1 is 2, to the power of 2 is 4, 8, 16, 32, 64, and to the power of 7 is 128, right? And to the power of 8 is 255. So now if I want to write 192, so I'm going to write first all these values here, like 128. You can just note down. If you want to pen down this, you can pen down 421, right? So how I am going to make 192? Very simple. Just take group of 128 plus 64. 128 plus 64 is 192, and put all the values which we are not using 0. Yes, very simple, right? So just take for 168, very simple, just take 128 plus 32. 128 32 is 160, and 160 plus 8, 168. And what would be the binary for this? It's very simple. All zeros, and in the last we get 1. And another one we are going to get 0, 0, 0, 0, 0, 0, 0, 0, 1. If you understand, just type yes in the chat section. Okay, cool. Now I'm going to show you why we have classes in IP version 4. Okay, let's go ahead. Yeah. So now there is a organization known as IANA, Internet Assigned Number Authority. Internet Assigned Numbered Authority. So what they have done, they have like they have divided the classes. Like how they have divided, like we are going to write the same thing here, like we are going to take one octet, like we have four groups, we are going to write the same here, to the power of 7, 6, 5, 4, 3, 2, 1, and 0. So just write down the values: 128, 64, 32, 16, 8, 4, 2, 1. Okay. So let's play the game. So what IANA has introduced, it actually made the groups, like in the first group, we are going to take all values 0. So it means what value I am going to get here? 0, right? In the second group, I am going to take 1 here, and rest all my values will be 0. And it means if we have 1 here, it means I am going to get 128 here. Okay. And in the third group, we are going to add 2 ones. It means what value we are going to get? 128, 64, 192. And here we have 3 ones, and we are going to get 224, right? And in the another part, we are going to take 4 ones, 240. And what would be the maximum if we plus all values? We get what value? 255. And what comes before 240, guys? That is 239. What comes before 224? 223. What comes before 192? 191. And what comes before 127? This is A, B, C, D, E. Enjoy. Okay. So this is how IANA formed IP addresses. And you don't have to cram every time. Just remember this formula. And so it's very simple. In the first group, we are taking all zeros. When we plus all zeros, we get 0. And here in the second group, in A class, all values are 0. In B class, just take one group. C, we are going to take 2 ones. In D, we are going to take 3 ones. In E class, we are going to take 4 ones. So that is the actually representation of, yeah. Might be some of you are thinking like I have gone through to hundreds of books. This formula is not in the books, or maybe over the internet. How this trainer knows these things? Or might be there are, but so it actually I'm just yeah, 127 is actually class A, but we don't consider this. 0 and 127 are reserved. So 0 and 127 is reserved. So how I got to know? Because when we ask questions from ourselves, why we have, like I used to, when I was in college, I was like I used to think in this regards, like why they have made the classes, right? So we always remember the classes, but we only like used to cram, but this is the exactly reason. Okay. And do you know this, like if you want to buy a IP address, you can't directly go to IANA. So IANA has formed uh, what we call this RIRs. So IANA has regional internet registries. So these are known as regional internet registries. Registries. So first registry is like America registry for America, ARIN. For Asia, that is APNIC. For Latin America, that is LATNIC. For Russia, that is ripe, and for Africa, that is Afrinic. So this is by continent wise, right? And if I'll discuss about Apnic because I belong to this. So that is Asia Pacific Network Information Center. Okay, Asia Pacific Network Information Exchange something. So you can just check it or Google it. So I highly recommend you this to go on. So if I want to buy IP address in India, so this I want to go directly to Apnic, not to IANA. If I want to buy a IP address in America, I will contact Erin. Yeah, INA is not a yeah, it's a kind of government body, but now it's what we call this. It's for all. Kind of it's a government body, but it's an organization now, or like what we call this WHO. It's a or a government, or it's a global organization, right? So it's like that kind of. Yeah, centralized. Okay, so are in Apnic, Latinic, Ripe, Afrinic. So America Registry Information Numbers, Asia Pacific Network Information Center, Latin America Network Information Center. So that stands for RESUX Internet Protocol Exchange. That stands for Africa Network Information Center. Okay, so go and check it. So now, one question that arises, from where we are getting internet. Like I'm getting internet from one ISP, that is Airtel. But from where Airtel is getting the connection? Maybe from different ISP. Maybe let's take AT&T. From where AT&T is getting the connection? You must be thinking that maybe they are taking connection from somewhere or some kind of ISP. It's not like that. So internet, I told you, internet is a network of networks. So Airtel, AT&T, Sprint, when they are actually connected each other, when all the ISPs in the world, like Tata, like Telstra, all companies or all like all ISPs are connected together, they are actually making internet. So internet is not coming from anywhere, right? It's a combination of all the networks are connected. Yes, correct, Rudresh. Okay, so it's a history, like how it started. I'll give you the overview because it actually motivates and gives interest or creates interest to learn networks. So when there is a Cold War between Russia and India, okay, not India, sorry, there was no Cold War between Russia and India. So Russia and USA. Yeah, yeah, I do remember. So my bad. Yeah. So Russia launched a satellite, their first satellite in the space. That is, I think, Sputnik something. Okay. So they have sent one satellite over the space, and they are getting signals. And when they are getting signals, somebody is jealous, and they actually made two organizations. That is a DARPA and NASA at the same time. Means um, it can be a delay between them, but they actually started two organization. You already know this, right? So DARPA is Defense Advanced Research Project Agency. So actually what they have done, so they have like in USA, they have underlaid the cables to connect multiple defense sites. Okay, maybe New York, maybe somewhere another areas of US, right? Dallas and all, Texas and all. So all the areas are like under the cables are under these cities are connected for the connectivity between army projects, or maybe something is going with, right? So basically this group is made to create a network so that all the cities or all their armies can communicate with each other. So when this project got famous, they actually released a public version of it that is known as Advanced Research Project Agency, that is ARPA. They formed another ARPA. Okay. So ARPA means when they launched this, they asked like when we create a big company or big, like suppose I'm a builder. Okay, I'm making a very big, like I'm making 1,000 flats or maybe bigger or big project. So I'm going to ask investors to put down their money in my project, right? So when Advanced Research Project Agency came, like some investors, like those are known as now ISPs, like they came into picture and they invested to put down the cables to connect the cities. Like when people are actually investing to create a big network, now they are known as tier 1 ISP. So what is tier 1 ISP? Those who actually invested in the cables, so that is known as tier 1 ISP. So there is a like to become a tier 1 ISP, tier 1 ISP is like the king of ISPs, you can say that. So tier 1 ISP is actually giving connections to tier 2 ISPs. There are a lot of tier 2 ISPs in the world also. All they are taking connections from tier 2. For the backup, they are taking from multiple tier 1s. And these tier 2 ISPs are giving connections to the local ones, which are known as tier 3 or local ISPs. So these are tier 3, or we can call these local ISP. So these are very small ISPs, like maybe you have in your hometown, but it's not in another cities, tier 3. And users can connect to these ones also, and these ones. So who are tier 1? Like I remember few names like AT&T, level 3, okay, Sprint, Comcast cables. So these are from all US. So in Canada, it's I think Rogers Cable or maybe, right? In Australia, it's Telstra. In India, only one name, Tata Communications. Japan and all, they have Singtel. Like there is another one, Entity Communications. So you can just Google it, tier 1 ISP. You will have around 15 to 20 names. Means only 15 to 20 ISPs in the world are actually investing in big projects. And that big projects actually, they are investing in most of submarine cables. So I'll show you the last thing of this class today so that you will have good dreams of submarine cables. So I'm going with the map submarine cable. Okay, just go and check this website. Okay, so all these are cables under sea, which is actually connecting all of us to have this Zoom session. This is the main purpose. Okay, so all the countries are connected, and if you check Tata here, so there is a lot of list here. So I can just click on the list, and you can see this is a cable which is known as CCOM, which is actually a 15,000 kilometer cable, which owned by Tata. So I can check another. So why Tata is tier 1? I am showing you why Tata is tier 1, because they are not actually, Tata is from India, by the way. Obviously most of you know, but yes, why Tata is tier 1, I'm giving you example, because they are not actually only investing in connecting India. Even we are even Tata is from India, but they are actually connecting UK to France, Spain, and Portugal also. So you can see this cable is a Tata TG in Western Europe cable, and it's not coming to India. So everyone used to think Tata must be deploying or uh, adding these cables for India. No, Tata is a like an investor. This is the reason they are known as tier 1 ISP, right? So this is how we check. And if you want to see any particular location, or any, if you are from USA and all, so you can see these are sub C points. So you can check any of the cable. This cable is implemented by Vodafone, and Vodafone is, by the way, from UK. And but this cable is between UK, France, and US. So it's very interesting map. You can always check this. Okay. So guys who came late in this session, and if you want lab access, you can just put down your email ID and we are going to create. Obviously, see, when we asked for the registrations, we got around 340. Obviously, we have only 100 seats for the lab, right? And this is a testing we are doing for our racks. So yeah. So don't type again and again if you have already typed your email address. And okay. So I think it's enough for today. We can't learn CCI today or CCNA in one class. So it takes time. But first we need to create interest in this network field. Then only we can go up to the top level. Trust me, if you really love this technology, you can have like thousands, or maybe like if I'll talk about USA, you can go up to 150 or 2 lakhs dollars, up to in not as a fresher, but it takes time. And in India also, like, you can go up to 50 lakhs, 60 lakhs also in this particular field, but it takes time. You can't jump to 50 lakhs package within 1 year or 2 years. It takes time, right? So I'll show you, or I'll give you one career strategy also, what exactly you need to learn in 2021. Obviously 2020 is going, so we will discuss about 2021 plan also.
Hi, you are watching the recording from one of our live session. Hit like, share, and subscribe for more future updates.
So I have explained you what is a network. When two or more devices are connected together is a network, right? And like, you can connect your computers, printers, or laptops in a network, and that is also a net, that is also known as network. And one, when all of the service providers are connected together with submarine cable and all, so that is also a network. So I have also explained you that there are tier 1 ISPs in the world, which are giving connections to the tier 2 ISPs, and further tier 3 ISPs are taking connections from tier 2 ISP. Right. So Tata, AT&T, Sprint, the bigger ISPs are known as tier 1 ISP. Those who actually invest in the submarine cables, right? And tier 2 ISPs are like the normal ones, like in India, we have Geo, Airtel, and all. These are tier 2 ISP. So I'm audible, right, guys? No, this is not a YouTube live. This is Zoom live only. Okay. Yeah. So we are going to discuss today that OSI model and TCP IP. So first of all, we need to remember these layers. So starting from top, that is application, presentation, session, transport, network, data, and physical. Right. And we are not actually using OSI model in real networks, because OSI is a reference model. This is the reason model is known as reference model. Just to understand about networks and how actually packets travel from one source to destination, we actually learn OSI model. Even in the Cisco books or even any vendor books, you will understand OSI model first. And in real world, we are actually using TCP IP. So the combination of application presentation session layer is application in this TCP IP, and in transport we say transport the same in TCP IP also. Here we have network, here also we have network, and the combo of data link and physical, we can say that network interface. But now the TCP IP is also updated. It means, so it means data link layer is known as data link layer and physical is known as physical. So earlier TCP had four layers, but now we have TCP IP updated version in which we have five layers. First is application. Okay. So that is transport. We have network, we have data link layer, and last we have physical layer. So in nowadays in TCP IP, we can say that we have around five layers. Application, which is actually the combo of these three layers, application presentation session. So when we want to learn IT networks, then we always learn with the OSI model. And if you understand OSI model, then TCP IP will be very easy to understand. Okay. So we'll be starting with the OSI model, and then we will go with and check TCP IP also. Okay. So, but yes, we need to understand first this OSI model. So there is a alliance to learn this. Like all people seem to need data processing. Like all people seem to need data processing. Or you can say that please do not throw sauces, pizzas away. So it's just allies so that you can understand or learn the layers in order. Okay. So what? So every time when we learn about IT networks, there is a term called protocol. So what is this protocol means? So protocol means a simple set of rules, right? A protocol is known as set of rules. Like suppose you are driving a car, you need to follow some rules, right? So the government of that particular country is already made some rules that you need to drive or at the right side or the left side, right? So there are rules, right? So the rules we have over the internet also, these rules are actually known as protocols. Like when we say transport, TCP, IP, or these protocols. So these are actually rules. If anybody wants to go over the internet, they need to follow the rules. Like all Windows machines, all MacBook, or all routers, which is all are following the same rules. That is TCP IP. Okay, got it. Chintan, stop asking me lab questions. Ask me when we will complete this session. Okay, so don't distract me here. Yeah. So what I was saying, so like to reach internet or to follow, so OSI model TCP IP are rules so that we can follow the internet rules. So these are known as protocol. So like all these 4 5 routers are sharing the information with each other. So they are following some rules, right? So these rules are actually known as protocols. Hmm. So we have like which rule we are following? Everyone is following nowadays TCP IP. So all your devices like hub, router, switch, bridge, repeater, all actually works, not hub actually. So this actually slide is added to understand about the devices. So let's check this simple network, why all these devices are here. Okay. So yeah. Hmm. So you can see like we have an internet connection over here and we have placed the device that is known as a router. So why we have router here so that we can connect it to the different world. Means to connect with the different network we need a router. So these client means your computers, laptops or any device, and these servers are actually connected with hub. So hub is a obsolete device nowadays. Nobody uses hub, so we have instead of hub we use is switches. So switches are better than hub because like it works only on signals, but switches actually understand about the MAC address and other functionalities. Switches are better than hub, you can say that. Okay. So this is a simple representation that router is actually connecting to the internet, and all your hub or these type of devices are actually connecting your machines together. So that is little bit old one. Yeah. So there are so what's the difference between hub and switch? Yeah, so I was explaining that. So when like few computers are sending data, okay, so hub is just like your power extension device. So if a computer is sending data to B, it will also go to C, D also. So hub always do broadcast because it works on signal. So if you send any signal, it will go to everyone. So that is hub. It actually does not learn MAC address. Okay. So in when we use switch, so switch actually makes one table inside the switch. So that is known as MAC address table. So whenever you send data from A to B or C to D, so when we are sending data A to B, so A computer MAC address will be stored, B computer MAC address will be stored. So next time when data is sending or when data is going between A and B, so because switch knows the MAC address, switch knows the address of that B device, so it will directly go to B device. So it will not send to C and D. Okay, so this is the difference between hub always do broadcast. So what is broadcast? See this image. So when my computer, one computer is sending data to one device, that is unicast. Okay, when one device, either it is router or any device, sending to multiple devices, that is known as multicast. Okay, and when my device is sending data to everyone, that is known as broadcast. So in simple terminology, hub always do broadcast because hub never store any MAC address. It works on signals. So this is known as we can also say that it's a layer one device. So what is layer one? So in OSI model, layer one is known as physical layer, which works on signals, connectors, and all. Yes. So it's like a dummy device. It does not store anything, right? When we talk about switches, so switch actually store the MAC address. So store MAC address. So this is the reason it is known as it's an intelligent device. Whenever data is going between A to B or C to D, so it checks the MAC address. If we don't have any entry, then it is going to send broadcast. But one time it will, you can say that initially it sends broadcast because initially we don't have MAC address table. But when data is uh, sh- like going between the devices, it makes a MAC address table, and after that it sends unicast. So if I'm sending data A to B first time, I'm going to send broadcast, the packet will go to C and D also. But next time when we have MAC address table, when next time I'm going to send data between A and B, I'm not going to send data to C and D because that will be unicast. So initially, till the time we don't have MAC address, we will send broadcast, and once we get the MAC address, we send unicast. Okay, so this is the difference between hub and switch. So we don't use hub nowadays, by the way. Okay, yeah. So I have explained you this network interface card. It's a chip basically, and we put this NIC card in the like motherboard PCI slot. But nowadays, all machines like computers, laptops, they have integrated Ethernet chips or NIC card inside the machines. So this is the image of hub, but nowadays we don't use this devices. And a hub actually have in hub we used to have this less number of ports. Okay. And by the way, what is bridge? So everybody is confused between this bridge and all. So Initially the devices, like when we want to connect all our computers, we always uses hub. But when we are going to use hub everywhere, what will happen? There will be a lot of broadcast in our network, right? To mitigate this broadcast, there like one device came, that was bridge. So bridge work was to just connect the hub so that we can reduce the broadcast, because bridge was the device which actually store the MAC address. So it actually not eliminate, it can reduce the broadcast. So like whenever any packets are going, it will go into this area only and this area only, like this. Okay, but bridge also is a obsolete device, because the combination of hub plus bridge is now known as switch. Okay, so hub was to connect multiple devices and bridge is to actually reduce the broadcast, because whenever any host A is sending data, so bridge will store the MAC address of host A and sending data to host C will reply, and we will store the MAC address of host A and C also. So next time when we are sending data between host A and C, bridge will show us the MAC address table and we are going to send the unique cast kind of packet, so that we can save the bandwidth. Yeah, so switch is like successor of this device that is known as bridge. So switches was bridge, you can say that. So now bridge is known as switch with many ports. In bridge we used to have less number of ports because the device made to connect the hubs, right? So you can see connected hub here, hub here. So it has less ports. Even hub was having less ports, but the combination, you can say that hub has a lot of, like 4 port. We in switches we have 8 port, 16 port, 32 or 24, not 32, 24, 48, like that. Okay, so now this device understand MAC address on every port. Okay, cool. Hmm. So these are the switches. Actually, nowadays Cisco has like you can see this. So this is a 16 port switch, the upper one, and the below one is 24, and in the last one we have 48 port switches. So that actually switches cost actually varies on the density of ports also, like how many ports we have in switches. Maybe 16 port switch is $100 and 24 is $150, and maybe 48 will cost around $200. It depends on which model you are buying. So now comes the router. So again, router is a network device which is used to connect different networks with each other. So in when we talk about routers, we don't have the small routers. So you can see this big router over here, that is used by big companies, or you can say that used by service providers. Okay. So yeah, just hold on. Yeah. So when we talk about the normal Cisco devices, we have around 4,000 series. Okay, 4,000 series is like branch routers. Okay, and these routers are not very costly, but yes, it's the starting range of Cisco. In market, the devices we have of router, so again this device is very costly in terms of the local routers or any local company routers, right? So these are known as branch routers, and these routers are like Cisco ASR routers, aggregation service routers. So these small routers are known in Cisco ISR, integrated service router. When we talk about ASR, that is service router aggregation service routers, and ISR is integrated service routers. Okay, so this is the category ISR, ASR, and Cisco has I think one another category, that is, I forgot the name. Yeah, CSR. What was the full form of this? Carrier segregation router, something, right? So that was carrier segregation or something router. segregation, or you can check or Google it. So these are the biggest routers, like 10,000 series, 11,000 big series. So again, these are used by service providers. Okay, so same it goes with another vendors like Juniper and all. So they have PTX series, they have MX 2020 is the biggest device, right? PTX 10,000, or like the smaller ones are like uh, 560 and all. Okay, so these are the model names. Okay, let's come back to OSI model now. Okay, so that was just a quick reviews if anybody joined session from today onwards. So yesterday we have covered these things like network fundamentals, router, switches, and all. Yeah. So let's start with the application layer. What will happen and what exactly this layer means, application. So application means any softwares which interact one human to another is comes under application layer. Like your web browser uses https protocol, right? So when you use https, when you are sending email, telnet, or so all these protocols comes under application. Okay, yeah. Okay, so there are many protocols I'll discuss in detail. Okay, these application, but just understand, if anybody wants to communicate with another user, from if one human to another, you can say that. So they are going to use something, right? You want to access website, you will use HTTP or HTTPS. You want to send a email, you will use simple mail transfer protocol to send a email. To receive email, you will use POP, Post Office Protocol, or there is another protocol, IMAP, Internet Message Access Protocol. So these all protocols are used by emails so that you can send or receive the emails. So these two protocols are used for www, World Wide Web, so that you can access the websites, right? So there are a lot of protocols which falls under application layer. So whenever, like file transfer protocol, to send files to the server, we use FTP. Okay, so these protocol, and if you want to access any device remotely, so you are in India right now and you want to access a router which is in USA, right? So you are in India, so you are working as a network engineer for any US company from here. So you can directly access the router from here. Okay, so that is Telnet, and there is a secure version of it that is known as SSH. So that is for to remotely access the devices, right? Yeah. So these all, if you see from application point of view, all we are doing, we are using these application for sharing data. So we are accessing the websites, we are sending emails, we are sending files, we are actually accessing the router switches or maybe the servers from internet. So these all falls under application layer. So any softwares or any protocols which interact one human to another, or maybe you are interacting with any protocol, or you are sending data somewhere, so you are actually falls, these protocols comes under application layer. Okay, so now the second one is, or you can say the sixth layer, because seventh is the application layer from top to bottom, sixth layer is presentation layer. So what does this presentation layer do? So presentation layer actually tells about the format of data. So what is this format of data? So format of data means when you see a web page, either it is a google.com, youtube.com. So let's suppose youtube.com. Okay, so you see images, thumbnails of videos, you are watching a video over here, comments and all. So the data you are actually seeing right now, so the data is coming from YouTube server in the form of some code or some HTML or some type of format, but it is actually showing you in your format, right? So because directly video is not coming, so maybe the URLs or maybe the links of videos are coming, so that it is keep the video is going to buffer from the servers, right? So what I'm trying to say means the data you see on your screen is actually uh, converted, or you can say that this presentation layer helps us to show the representation of data, or the like images in multiple formats like PNG, JPG, audio is in multiple formats, video is into multiple formats. So it's a presentation layer responsibility to show the data in the correct format so that you will understand. Okay, and it is also responsible for this encryption, decryption, because if you want to encrypt any file or folder, the presentation layer is responsible. Again, this is a reference model to just understand, but in real world all comes under application layer, because all three layers all three layers, right, is known as application in real world. So when you say in real world, the format of data is actually taken care by application layer. Okay, but here when we discuss a OSI model, it falls under presentation layer. Okay guys, so when now the data is also this in this presentation layer is also responsible for compression and decompression, means to reduce or increase the size of the files. So these two layers done, right? So applications means the applications which interact one human to another. In presentation layer, just remember the keywords. Just remember the keywords. The keyword is here, the applications or the software which interact one human to another, or maybe you can learn the protocol names. And in presentation layer, the keyword is format of data. So just remember the format of data. So when the data is moving to session layer, so session layer is actually creating and maintaining the sessions. So whenever you open any bank website, right, so it has a time limit. So if you don't use your like if you are away from keyboard like for almost 5 minutes or 10 minutes, right, the session will automatically log out if you are not using your screen, or you are not using mouse pointers or anything. So the session will log out automatically. So why? Because this session layer is controlling that time frame. So whenever developers actually makes websites or applications, they actually code that time frame with the session layer algorithms. So suppose if I'm uh, let me okay, suppose I'm using one bank, suppose HSBC bank. Okay, so in this bank, I'm not using this screen for almost 10 minutes. So HSBC website is actually coded with by developers. It it's integrated with some session programs, like the session will log out after 10 minutes or maybe 15 minutes. So all falls under this session layer. So session layer means the time frame in which the session will be controlled. This session layer actually create and maintain the sessions with the time frame. Okay, so all three layers clear. So application means the softwares or the applications. In this we actually takes care of format of data. This is the keyword. And in session layer we actually create and maintain the time frames. Yes guys, nobody is responding in the chat. What happened? Hello, hello. Okay. SNMP will discuss, that is a network management protocol. Okay, great. Okay, so all three falls under these three, and all three layers are in real world, they are known as application layer. So you will not find actually presentation layer or session layer or application different in real world? Because in real world all falls under one layer, that is application. Okay, clear? Hmm. So now this is very important layer of, so that is transport layer. So now when we discuss about three layers, so the data is in which format? Data. So now when the data comes to transport layer, it actually converts the data into segments. It means it will divide the data into multiple chunks or parts. So whenever from above layers we are getting data, and transport layer is actually converting these packets into segments. Okay, means you are getting a data. Okay, suppose this is data, not just hello, I'm just giving an example. So when the data is going to transport layer, it is actually segmenting the data into multiple parts like this. So again, hello is very small, so I'm just explaining you what is happening. So the data is actually converting, and so this is known as segmentation. Okay, and also this transport layer is responsible for sequencing. What is this sequencing? So it will actually add the number on the data. Why? Because when data is going from one PC over the internet to any another device, uh, over the internet or in your LAN network anywhere, so the data is traveling, so might be there is a chance the packet will be drop. And when the data is going to B, so B will check, okay, I got 1 3 4 5, I haven't received the second number sequence, can you please retransmit, can you send me again? So in this transport layer we actually do retransmission also. Okay, so transport layer is responsible for multiple things, so like sequencing, segmentation, retransmission, all this stuff. But transport layer actually divided into two protocols. So all this retransmission, segmentation, sequencing all comes under TCP. Yes, Nikhil, correct. Sequencing is used so that we can assemble or reassemble the data at the destination end. Okay, so that is the overview. Now let's start transport layer. Okay, so in transport layer, I have explained you the data is divided into segmentation. But before doing that, so the now data is coming from above layer. Okay, so now you can just say that we have, so the data is going in, we have two trucks over here. So one truck is known as, you can say that it's a TCP, and this is a UDP. So now data, either if data is going with this truck, what will happen? So whenever we send any data with TCP, whenever, so this, any packet is going from source to destination, so the destination is going to send us back a receipt, that is known as acknowledgement. Means if the data is going with this guy, okay, it is going to take, or it is going and coming back with the receipt that I have delivered the data. But when data is going with this, with the UDP, we are just sending the data, but we are not going to get back the receipt of whatever we are sending. So it means whenever we send data with the TCP, so TCP stands for Transmission Control Protocol, Transmission Control Protocol, and UDP stands for User Datagram Protocol. So whenever data is going with TCP, so it actually takes care of acknowledgements. So tell me, if anybody is coming with the receipt, who is more reliable, TCP or UDP? Because it is coming back with the receipt that I have delivered the data, so this is reliable. Where this person or this UDP truck is not reliable, right? And if data is lost, if suppose we are sending data, one box dropped somewhere in the road or somewhere, so the vendor is actually take or count the boxes, how many boxes we got, right? And it actually says, oh, please send me one box again, or maybe the box is broken or something, so it is going to retransmit the data. So we don't have any retransmission over here, no retransmission. So if data is dropped or discarded or anything happened with the data, it is going to retransmit the data, right? Yeah. So this is known as, it always believes in connection. So this is, in network language, it is known as connection oriented, because it always believes in making connection, but this is connectionless, right? So UDP, so there is a term called fast in UDP, but nowadays our internet is super fast. So we don't have to say that TCP is slow or fast or something. So you can skip this line. It looks like very childish if we speak like this is fast or slow like that, because now, yes, you can say, yes, correct. So you can say, like one guy Sharath has given a very good answer. So it has less overhead. Less overhead means whenever we sending data, we don't actually send a lot of many things. So it means there will be less size of the packet in comparison to TCP. So TCP takes 20 bytes and UDP takes how many bytes? I think 8, right? 8 bytes. So any data, any small box or any packet going with UDP, it is going to take 8 bytes, and in TCP we are going to take, on every packet I'm going to place my address, that is 20 bytes. Yeah. So TCP, there is a protocol number to it. TCP protocol number is 6, because these both protocols falls under IP. So IP is the biggest or main protocol. So TCP works under IP and the protocol number is 6, and UDP works also under IP, that protocol number is 17. Again repeat, okay? So see, in transport layer we have two protocols, TCP and UDP. So whenever we send data from TCP, we always get acknowledgement. Here we don't get acknowledgements. So this is the reason it is reliable and it is not reliable. So whenever anything happens with any packet, it is going to retransmit it, and here we don't have retransmission. So this is the reason we also say that it is connection oriented and this is connectionless. So TCP takes 20 bytes to add information and UDP takes only 8 bytes to add the UDP information. So what is that information? That is port numbers. We add port numbers here. So the bytes I'm talking here, 20 bytes, 8 bytes, it actually adds port numbers. Okay. So suppose you are sending data from your computer. So computer is going to add one port, and destination port will be like you are going to HTTPS and all. So it is going to add the port number. So we will discuss this also. So just understand this in transport layer right now. So connectionless means, connection oriented means it all believes in connection making. It is going to retransmit it, and it always means, connection oriented means it always believes in making connections. Connectionless means if anything happens or packet has dropped, we are not going to retransmit and all. So this is the reason you can say that it's connectionless. Yeah, not trusted. Yeah. So we don't, this is not reliable or not trustworthy. Connectionless is just a synonym of this, you can say the reliable. Okay, so what we have learned so far, the data is coming and data is coming to transport layer. Transport layer is actually converting those into segments, right? So which layer is converting? Transport layer. Okay. So now the data is moving to which layer? Network layer. So now segments is actually converting into packet. Means the data is here. It's like a gift wrap, you can say that. Data is here. So on top of it, we are going to add extra header that is like source port number. Okay, source port number, destination port number, and this whole is known as segment. So that is known as encapsulation also. So whenever you add something, that is encapsulation, or whenever you remove something, that is a decapsulation. Okay. So data is actually going inside a segment, and now on top of it we are going to add a extra few things that is known as now packet. On top of it we will have another thing that will be known as frame. Okay, so packet will have source IP, destination IP, and frame will have source MAC address, destination MAC address. There are a lot of, okay, okay, so I'll explain in more appropriate way. So I'm just giving you idea. Yeah. So packets. So in network layer, all your routers and all works under this network layer, and packets actually adds the source IP and destination IP. So whenever we talk about the IP address, this segment actually adds the port numbers, and in packets we add the source IP, destination IP. End-to-end delivery means it is going to take care of all the responsibility of sending data from source to destination, because the transport layer is choosing which protocol is going to carry forward your data. So this is the reason we have written here end-to-end delivery of data. Okay, so packets is now moving to another layer, that is packets are going to convert into frame, and this which layer is doing this? Data link layer. So data link layer, or like in network layer, your routers works here and switches works on this layer. Okay, and frame is actually adding what information? Like in segments we have port number, in packets we have source IP, destination IP, and in the frame we have source MAC address and destination MAC address. Okay, and all your frame is now going to convert into signals, because your computer is going to send data, right? So all data is going from top to bottom. So now just see from, this is a computer. So just understand this is a computer. Now physical layer means your NIC card is going to convert into 0 and 1 form, that is known as encoding. Encoding means converting, or encoding, decoding is converting the data into 0 1 format and converting them into signals, so that this computer is sending data to another computer. Okay, so this whole process is known as encapsulation, and also the data is going over the cable now. And whenever the second device, which is over here right side, you can't see, just understand, or we can place here, just hold on. Yeah, so now data is coming into another PC here. Let's take example. So now data is going 01 form again. Here we have physical layer. So we got 01s. It is now physical layer is giving data to data link layer. So data link layer is actually converting this into frame. It will check the MAC address information. Okay. So computer will check its MAC address. So this computer is suppose B, this is A. Okay, so when we open this frame, we get what? Packet. So when we in packet, we will check the IP address. So the packet is for my device or not. Okay, if a device IP address or the packet IP address match with this computer address, it means this is this computer information, this packet came for this computer only. So packet, when we open the packet, we will receive the segment. In segment, we check the port number, which application this computer is trying to access, which application. And when we open the segment, we get what? Data. So this is how it works. Okay, cool. I'm not explaining in very complex way. I'm just trying to explain in a very layman language so that you will understand. Hmm. Thanks. Okay, so now let's revise again. So I told you application layer. What is the keyword? All applications. Like you can remember with the one human to another human, or you can remember with the keyword all applications, or like HTTP, SMTP, all comes under as this. Okay, application software which help interact one human to another human. Okay, very basic. So in presentation layer, what was the keyword? Format of data, right? Format of data. So when we talk about the uh, compression here, compression, decompression, encryption, decryption, all falls under in this layer. So when we go, the data is going to session layer. So what is the responsibility of session layer? Create and maintain the session. Create and maintain the session. Okay. And when data is going to transport layer, so transport layer is responsible for end-to-end delivery of data. Means it is going to take care of all the delivery part, end-to-end delivery of data with the help of two protocols, TCP and UDP. So where TCP always send acknowledgements, where UDP does not send acknowledgements. So TCP has a sequencing. Okay, put down the number over the packet. Okay, segmentation, divide the data into parts, retransmission. So all falls, all these work under transport. And now the data is moving to here. The data is known as data. So now data is known as segment here, right? So now the data is moving to which layer? Network layer. So where we are going to add what? Add IP address. Here we are going to IP address. So IP address, either it would be IP version 4 or IPv6. So network layer is going to add the IPv4 or IPv6, any which you are using. So in data link layer, we are going to add what? Add MAC address. So MAC address means the chip hardware address of NIC. Okay, and the physical layer is actually converting your all data into 010101. So that is encoding. Okay, clear? Got some confidence or not? Okay, so let's do a small quiz. OSI model quiz. Just check from over the internet. Okay, so we can open this one. Let's do a small quiz. Hmm. Okay, please participate. Okay. So tell me how many layers we have in OSI? 7? Good. Hmm. Okay, so tell me on which layer I told you that router works on which layer? Yes, IP address. Where we have IP address? Yeah, network layer. Okay, name a protocol that operates at transport layer. So I told you two protocols, TCP. So I'll write down TCP. Yeah, so you can either you can write UDP also. So both works under. So the network is which OSI layer? Network layer is known as which layer? Layer 3. So I'll write 3, third, or maybe just write down. Let me write 3. Hopefully it will be. Yeah, so you can write third, 3, 3, or third, something like that. Okay, so which layer manages the reliable transfer of data from host to host, means end to end, which is actually taking care of delivery of data. Transport, we don't have option of TCP, so we have to choose transport. Cool, right? So tell me really encapsulation. So tell me encapsulation. I told you encapsulation occurs at all layers, true or false? True, right? I told you that adding anything and every layer is adding something. Oh, but we got false. Why? Because few layers are actually not adding. Because this question is regarding OSI model, and I told you in real world we have application. So maybe so it's a tricky question. Encapsulation actually occurs when we add port numbers, when we add IP address, MAC address in like physical network data and transport. Okay, so the application layer is not adding something. So maybe this is the reason, but no issues. The session layer communicates with which other layers? So session layer is between which layer? Transport and presentation. So I think this would be the answer. Yeah, correct. So the session layer is between transport and presentation. So the question was like that only. So what is the name of the layer that selects the best path for data to be transmitted? I think I have not explained this. Means actually the device router actually selects the best path. So tell me which layer or which router works on which layer? Network? I think this would be the answer. Yeah, correct. Network layer. So router chooses best path. If you want to go to google.com, right? So data link layer works on which layer? Okay, so which devices actually work on data link layer? Which operates with the MAC address, that is switch, not hub. Hub works on physical layer with the signals. Data link layer takes care of MAC address, and I have explained that the MAC address switch store a table that is known as MAC address, right? So that is some error correction detection. So error correction I think works on this layer 2, layer 4 maybe. Layer 2, 3 something. Yeah, 2, 3. Okay. So we have done, we got around 8 to 9 questions correct. So again you can check. So means what I'm trying to say, like at least you got now when you will see OSI model questions, you will not be completely blank if you really want to give any exam like CCNA or anything. Okay, or maybe the CompTIA Network Plus. Okay.
Hi, you are watching the recording from one of our live session. Hit like, share, and subscribe for more future updates.
Okay, so the second thing, now I'm going to show you how to download Packet Tracer, which is a free software by Cisco. So first you need to make an account on cisco.com, which is very simple. Just go and make it. So once you create your account, then go to another website that is NetAcad, that is Network Academy. Okay. So in Network Academy, you need to log in with your Cisco username password. Yeah. So go to Net Academy, log in with your Cisco username password. Okay. Yeah. So you can see once you log in into this Network Academy, on the resources section, so you can see download packet tracer. Okay, so once you download this, so you can see here Windows desktop version and Linux or Mac OS. So even I can share the direct link of packet tracer and all from here also. But the problem with this link is that you still need to create account. Okay. So even if I'm going to add a direct link here, even already shared this, right? But you need to create the Cisco account because in Packet Tracer nowadays you can't log in without entering your Cisco ID. Okay, so I'll show you just a quick overview of this software also. So it's asking me to log in again. I have to type the same ID which I was typing there. Okay, and the same password which you created for Cisco ID. This is a little annoying every time you have to log in into the software, but it's okay. Yeah, so my software is ready. So this is the software which is known as Cisco Packet Tracer. And if you want to do the lab, you can just create or add a lot of devices, multiple devices. Okay. And here you can create the switch. You can add a cable from here. Okay. So you can also do the same commands. You can type the commands of switch also just by clicking here, CLI. So here is the console. So from your means you can install this software into your PC, okay, and start doing basic labs. Okay. So this is overview of Packet Tracer. Okay. So let's go further, guys, and let's quickly review the OSI model which we discussed yesterday. So in application, what happens? The softwares interact one human to another. That all protocols like HTTP, HTTPS, SMTP, Telnet, POP. All the applications works under application layer. So whenever any layer is actually deciding what is the format of data, either the image is into PNG format, JPEG format, or audio in MP3 or WAV, video is in MP4 or AVI. This layer is also responsible for encryption, decryption, compression, decompression. So all comes under presentation layer. So now we have another layer, that is session layer, which actually create and maintain the session within a time frame. Like if you are opening any bank website, it takes around 10 minutes, right, to log out automatically, because that is a time frame which is actually created with the session sockets or session programming. So this session layer, just you can remember this, it's responsible for creating and maintaining the sessions. Okay. So in transport layer, we have end-to-end delivery of data where we get TCP and UDP. So TCP is a protocol where we get acknowledgements, but in UDP we don't get the acknowledgements. So just check the second day video, the link already shared here. If you are attending this session today, so you should watch these two videos, which are yesterday and the day before yesterday video. So in network layer, all the IP addressing and the IP address is added over here. Router works on this layer, and the packet, uh, in transport layer we have segments, but segments are now converting into packet. Packet means the IP address of source and destination is added into the packet. So we have data link layer, which actually may adds or MAC address information in the packet, and that is known as frame, and switches works on this layer. And physical means your cable connections, all connectors comes under physical layer. So this is the overview of this OSI model. Okay. So guys, today we are going to do subnetting, which is very important part. Most of you were asking for it. And if you still remember classes, that class A 1 to 126, B stands for 128 to 191. And I'm not going to explain only subnetting. We are going to do small practical with the subnetting part also today. So 192 to 223. Okay. So just you need to learn subnetting with ABC. So D or E classes are actually not used with the host. Means you can't give D or E class to the computers, because D is reserved for multicasting. So what is multicasting? You can just take one example. When all routers in a network wants to communicate with each other, they are going to communicate, or they are going to share information with routing protocols. So these routing protocols are working on multicasting. So you can just take that example. So multicasting means, from multicasting they are sharing their information to each other. Okay, multicasting is like reserved IPs, and E also, that is known as like future use or something, but it is now wastage. So why I'm saying wastage? Because they thought like, once we have shortage of IP address ABC, we are going to use class E in future. But no system, like not Windows, not even Linux, not even Apple or Mac OS, not any single operating system support E class, because initially it was meant to be used in future use, but we can't use that IPs now because no software in the industry supports class E. So ideally you can say that it was reserved for future use, but now it is now a wastage. Okay, we can't use this. Clear? Just say yes in the chat. And please keep interacting in the chat, yes, no, something, so that it will give me boost also, else I will feel bored, right, to train. Because when I usually take my live classes, I actually ask students to raise the hand and they can speak with me. But yes, this is a public session, so it's always better to have discussion on the chat. Okay, so let's understand what is subnetting. So what is subnetting? See, class A, B, C. So in class A, we have first part is network. It means if any computer is connected to another computer, an IP address is 1.1.1, another IP is 1.1.5. So for the we need to check the first part, right? And how computer checks the first part? Because we give one thing that is known as subnet mask. So whenever you give IP, there is one extra information is added automatically that is known as subnet mask. So what is this subnet mask? It actually represents network bits. So it represents network bits. Okay. So subnet mask represents, yeah, Hemant, definitely. Okay, so this 255, it is representing that I need to match how many part? Only the first part. So class A is known as 255.0.0.0 also. So that is the by default subnet mask of class A. It is representing that only the first part is network and rest all part is host. All part host means in class A we can assign a lot many IP addresses. In B class we have two network part. So how computer understand? So when we give any IP like 172.16.1.1 and another computer is 172.16.2.3, so they are going to communicate with each other because their first two portion are matching, right? They are in same network. How? Because when we assign, the computer automatically takes 2 times 255. This happens automatically, you can try it out. So 2 times 255, it means the by default subnet mask is 255.0.0. In C, so that we have around 3 network part and 1 host part. It means we have 3255. So how many parts we need to match? So when we give any IP address to computer of class C, suppose 200.1.1.1 and 200.1.1.2. So like the first three parts, if both if both machines parts are matching up to three network, up to three octets. So it octet means one group is known as octet also because it is 8 bits. So three parts are matching, they are also able to communicate. So this means 3255.0. Yeah, I'll explain. So the IPs I have, so I'll explain private and public IP later on. So just you need to understand this first. Okay. So just type yes if you understand and then we can go on. Okay. Hmm. Okay. So now, so what is subnetting? Divide a large group, divide a big network or divide a network into smaller parts. So why we are going to divide the network into smaller networks? I'm going to explain you. So first of all, class A, it has network part, one octet network part, but rest three host. So it means 8 bit, 8 bit, 8 bit, right? This is also 8. So 8 means it has a 24 host bits. 24 host bits, right? 888. So to the power of 24. So how many computers, like one class A IP range class A subnet gives 167772216. That is the number to the power of 24. So if you start giving IP from 1.0.0.1, it will go up to 12552552554 almost. So you can start with 0 and go up to 255. But the first IP and the last IP we don't use because of network ID and broadcast ID, that I'll explain later on. So you can just count these numbers. You can't even count these numbers manually. So it's a very big number actually. So that IPs is 167772216. The one subnet. It means one network of class A gives that much IP. So another, if I'm saying 2.0.0.0, so that is a separate one number. So that is, here we have that number also, and here also we have that number. So means these are two complete different groups. Each groups give that IPs. Okay. So in class B subnet, any subnet of class B, that gives how much IP addresses? That gives to the power of 16. That is 65,536. In class C, we have 3 network part and 1 host part. So to the power of 8 is 256. So C class networks gives 256 addresses, B class gives 65,536, and A class gives 167772216. Yeah, network bits always remain same. This I am talking about host now. I have already explained in the last slide, or what we call last, where I was drawing. So that I'm discussing now, host part. Okay, clear? Yes. Okay, good. So when I say class C, so class C gives 256 address. So it means 192.168.1. If the IP network bits are like this, so this will remain same, right? Because of network bits remain same. So it starts from 0, it will go up to 255. So 0 to 255, if you count this number, you will get 256 address. Okay. So if this class C IP is giving 256 address, and if I want to divide this into 4 parts or 2 parts, or I want to divide this network into 4 parts, okay, and I want to give 40 computers here, 40 prox here, 40 here, and 40 here, or maybe 50 computers also. So we can give that also. So we want to divide this network into 4 parts so that we can give IP addresses to these networks. Maybe I'm creating computer labs in my college, or maybe I'm creating some ODCs in my office. So I want to give 50 computers group in all networks. So if my requirement is 50, suppose I want to give IP addresses to 50 computers, but class C is giving me 256. So if I'm going to use 256 IPs in 50 computers, how much I'm going to waste? I'm going to wastage of 206 IPs, right? So that is happening. If I want to create 4 computer labs, either have to use multiple networks, and we should not have multiple networks. Why? Tell me. Most of you know 192.168. If you don't know this, this network is free. You can say that it's a private IP, and private IP is free. But why we are doing subnetting in private IP? Can anybody explain me? Or you can mention in the chat. Kunal, 192.168 series is private IP series. This is the reason. So in what is private IP? These are complete free IPs. You can assign or you can use it for anywhere. So in class A, 10 IP is private. Any IP start with 10 IP, that is private and free. So 172.16.0.02, 172.31.255 means any IP start from 172.16 to 172.31, all are private IPs. And in class C, we have 192.168. So any IP start with 192.168. So any IP start with 192, it's private IP. So I'm asking if IP addresses are so free, because in class C you are getting almost every network. You can use 1.0, 2.0, 4.0. So you can use all four networks in these computer labs because these are free, right? So why we are doing subnetting then? Hmm. Anyone from industry? Yeah, think for 2-3 minutes. Why we are doing subnetting if private IPs are free? Saransh, private IPs are like free IPs. You need to buy all IPs, right? So you want to use any IP address, you need to register it. But private IPs are like free, you can use it for free. And how you can't access internet with private IPs. If you want to access internet, you have to use ISP or internet connection, because internet connection actually gives you public IP. So when your internet, so you can do one thing. If you have Wi-Fi router or Wi-Fi device at home, so what you can do, you can connect all your computers. You can check if all are pinging together or not. And what you can do, you can disconnect the internet cable from your router and still check if they can communicate with each other or not. So they will communicate with each other. So that is my private network. Okay, so public means routable to internet. Private IP is not routable to internet. So my question was why we are subnetting when we can use free IPs. So I'll explain. So when you will have a router in your office, okay, and maybe you have four networks, or maybe you have different networks, right? So if this router has different network, 192.168, 1.0, 192.168, maybe 2.0, so it may be 192.168, 3.0. Okay, so if you have 192 series, that's okay, but maybe you have another 192.168, 99.0, something like that. So why it's better to always do subnetting? Because when this router is going to share that information to this router, so router will have all four networks. So instead of sending four networks information, uh, it's better to have one network only, because it is going to take less amount of space in the routing table. So what we are going to do, we are going to summarize, means instead of sending all the routes, I'm going to send something so that this router will get only one or two routes and can access anyone. So one another example, if you have very big site, you have thousands of or maybe hundreds of routers, all your company routers are connected with maybe big routers like that. Okay, so all these client offices, or maybe if you have your own branches, so all branch offices are like this. So all branch offices are going to send the information to you, and this router, okay, this router is going to have a lot of routes. So if you are sending four networks or maybe eight networks from everywhere, what will happen? It will have a very big routing table, right? It will have a very big routing table with a lot of entries. So if your routing table is very big, so it means there is a load on our router RAM. Like when we install a lot of softwares, what will happen in our computers? So they get slow down, or maybe they keep on restarting, or blue screen comes, right? So if you have a lot of many routes, what will happen? So your main routers can have a lot many routes, and can lead to either you need to buy a very premium hardware or very big router to manage these routes, or you need to short these ones. Instead of sending 4488 routes, I'm going to send only one route. So this is the purpose of subnetting. So means if router is sending 192.168.1.0 from here to another router, so router will have only one route, 192.168.1.0 in the table. But here I'm going to divide this network into four parts, and I'm going to create four computer labs. Now understand why we use subnetting. Yeah, to summarize, means instead of, see, if first learn how to divide a network. So why, before subnetting, I'm showing you why we do subnetting. Okay, so that instead of sending four routes, so tell me which is better, sending all four routes or just sending one particular single route to the another router. One is better or four is better? You must be thinking four is better maybe. No, it actually consumes a lot of RAM. One is always better, right? So just don't imagine this with two routers. Just imagine if we have 100 plus routers or maybe 1000 routers in our company. Whole, suppose if I'm working for Apple, Samsung, like these brands, they have offices almost in every country, right? And subnetting is all not only in private. Subnetting happens in public networks also. What exactly? Suppose you got a IP address. I told you you get IP address from IANA RIR, that is AppNic. So you will go to AppNic website and buy a IP address. Okay. So let me show you AppNic. Okay, so let's see if AppNic gives me two IP addresses, and why you need to have public IP. Tell me. I'll give you one real example. See, I have a server where we have installed the labs like racks.nwkings.com, and you guys can access this website, right? So this is a URL, but on this URL has some IP like 203 181.25 like that. Okay, so this IP is my public IP, and this IP I got it from where? From my ISP. Okay, so I just bought one single IP or maybe two IPs, that is known as static IP. So this is my static IP. And static IP I have entered into my DNS so that if anybody goes to racks.com, so it will redirect to this. Okay, that is a DNS entry I need to create in my website. Okay, fine. So static IP is to access anything from internet. So static IP is a public IP. So this IP is public IP. So why everyone needs public IP? So that you can access the servers, you can access the websites. So you need public IPs. And if any big company is going to buy a IP, suppose you work for Apple. Okay, so they have a lot of servers like iTunes, from where you can stream the music, like Apple Cloud, where you can store your images and all, or maybe something else also, right? Like Apple TV and all. There are a lot of Apple servers so that the users can access this from internet. So Apple have public IPs, right? So they have a network, public pool, 17 network, right? So they are going to assign these IPs to the server, you can say that, so that these users can access, put, take their selfies and upload to the Apple Cloud or something. So just take an example. Okay, or maybe you can take an example of Facebook. So everyone needs public IP to access something. Even this appnik.net, this website is also having one public IP. But if any company wants to buy IP address from a big organization like Appnik, you can't buy a single IP. If you want single one IP, two IP, you can directly contact your ISP. But if you want a very big, if you have a very big company and you want to get IP, so just click on get IP address. It will show you you can buy minimum 256 address from Appnik. You can't go less than that. If you want 50 IPs, still you are going to contact your ISP. If you need more than 256 address, you can directly buy from Appnik. That is Asia Pacific Network Information Center. Okay, got it now? So now if you have 256 address and you have a lot of servers, maybe you have 4 servers in Delhi, you have 4 servers in Mumbai, you have 4 servers in Hyderabad. So what you are going to do? Tell me. Subnetting or not? Right? You have to divide, right? You can't use one pool at one location, right? Else you need to buy a lot of public IPs and it will cost you Australian dollars. Annual membership fee 1994. You can multiply by 50, 60, whatever is the dollar in Australia. So this is the annual membership fee, and that is a separate sign up fee. I'm just thinking about those guys, those who have not attended, still registered the session. These things are not in a book, man. Okay, got it. So now you understand why we use subnetting. So tell me, subnetting is important to learn or not? People ask me, sir, is this subnetting important? So I always say, see, everything is important if you really love to understand. See, maybe in interviews, nobody is going to ask you. But if you really want to do wonders in this network field, and if you really want to become a good engineer or maybe a network consultant, you should know about these things. Abhinav, this is not permanent time period. You can keep on paying them so that you will still maintain your membership. But yes, IPs will be with you till the time you are paying. Okay, so let's do subnetting. So we got a pool from where AppNic. Okay, so let's create a data center today. So data center is what? When we have a lot of servers and we want that people can access these servers from outside world. Any limitation on number of users for IP address? See, public IP is even one single public IP is enough to access internet. Just imagine like if you are still a student in a university of almost 10,000 student, so tell me how many IPs they need to access the internet. They can still access the internet with one IP. How? Because these 10,000 computers will get private IPs, and all these private IPs are going to convert into one single IP. And with the help of a concept that is known as NAT, Network Address Translation. Okay. But when we are saying we have bought a pool of 256 IPs from AppNic, what exactly it means? I am talking about a company where they have a lot of servers, and from internet people or anyone can access these servers, or maybe they are uploading the videos or maybe images. Because in one just take an example, when anybody uploads the images in Facebook, so tell me, all images are going in one server or they have a data center with a lot of many servers? Lot of servers, right? So they will have a lot of servers. So they need a lot public IPs, or they can use one single IP. See, accessing internet, you can access the internet with one IP also. But if anybody wants to enter into your premises, or they want to access your servers, then you need public pools. Okay, got it? Where we need public IPs. Lot of public IPs are needed when you are actually a big company. Okay, so we got a public pool. Let's take example 200.1.1.0, and this is a class C. So we always say /24. What is this 24? This is known as slash value. You can say that. In A class, we have how many network part? One. So this is known as 8/8 because it represents 8 network bits. In B we have 2n. So this is the reason we say this 16. And in C we have 3 network part, and this 888 is 24. So this is the reason I have written here 24. Now I want to divide this network into 4 parts for my Delhi, Mumbai, Chennai and Kolkata location. Shehzad, keep your camera off. Okay. So I want to divide this network into 4 so that I can use to my 4 locations: Delhi, Mumbai, Chennai, Kolkata, maybe. Okay. Yeah, Rahul, correct. So how I'm going to divide this network? So it's very simple. So your IP address is of how many bits? 32 bits. right? So what I'm going to write here I have network bits and then I have host bits. So I have total 24 network bits and host bits 8, right? So by default, how many IPs we are getting? 2 the power of 8 is 256 IPs I am getting right now. With one, this network is giving me 256 IPs. How I have calculated? My total IP address is of 32-bit. If class is 24, the remaining 8, 24 plus 8 is 32, right? Yes or no? So the to the power of 8 is 256. So it means I am getting 256 address from one single, from this pool. But what exactly we are going to do? We want to give 50 to 60 IPs, or maybe we want to divide this network into 4 parts so that we can give this one network, we can divide this into 4 parts so that we can give this to multiple locations. Okay. So I have 8 host part. So tell me how many networks we want to create, 2 or 4? How many networks? 4, right? Darshan, you are in the class or not? Yeah, so we want 4 networks. Means we want to divide this network into 4 locations. So tell me how we get 4 when we have to the power of 2, right? How, when we get 4 when we have to the power of 2, right? So it means we will add 2 here. It means we will have 26 here. Okay, very simple. And from where we will get this 2? When we will reduce 2 here. It means 6 host bits. So when we want to divide this network into 4 parts, my network bits will be 26 now instead of 24, and I have reduced 2 here. Why I have reduced this? Because we need to balance it every time. I need total 32 here. 26 plus 36 also 32. I need to maintain this 32. So you can shuffle the numbers from here and there. I'll explain again. How many network bits we have by default in class C? Tell me. 24, and host bits 8. How many networks we want? 4 networks. So how I get 4? To the power of 2. So just check the power. So this is the power. So I'm going to add this 2 here. So because I want to increase my network bits. So that is 26 now. And I need to reduce that 2 number from here because I'm going to change this host bits into network part. So this is the reason I'm reducing 2 here. So I'm getting 6 here. So it means I'm going to have slash 26, and to the power of 6 is 64. So it means we will have around 64 IPs in every group. And what would be the network? The network would be slash 26. Simple or not? Right? Let's take one another example. If I want to divide this network into 8 parts instead of 4 locations, I have 8 locations. Instead of 4, we have 8 now. So again, by default 24, we have 8 here. So how we get 8? When we have to the power of 3. So I'm going to add 3 here, 27, and I'm going to reduce 3 here. That comes 5. So to the power of 5 is 32. So it means we will have 4 8 groups, and every group is of 32 IPs. Yes, Adil. Okay. So now the question is how I am going to write these IP addresses. Okay, so we were making 4 locations. So let's go back again with the 4 question. So again 24, I have 8 by default. So to get 4, my to the power of 2. So I am going to add 2 here, 26, and I need to reduce here, that is 6, right? So what is, so when we are going to assign the IP, the first location, suppose Delhi, so IP address would be 200.1.1.0. Okay, so how you calculate your 4 locations? There is a simple maths. So IP address always start with 0, okay, and it always ends with 255. Deepak, if you have 7 locations, obviously you need to divide the network into 8. You can't divide in 7 or like that. So that also in the increments of 2, either you can divide into 2 or maybe 4 or maybe 8. So if you have 7 location, you can divide this into 8 parts, and you can save one few IPs for future use. So it's like yeah. So 26. So to the power of 6 is 64. So how I'm going to write this 64? So just add zeros in the starting. 0 plus 64, 64. So again plus 64 plus 64, 128. 128 plus 64, 192. So before 192 we get 191. Before 128 we have 127. And before 64 we get 63. So this is how, so the IP address from 0 to 63 will be placed in Delhi. So here we are going to assign in Mumbai. Here this IP we are going to assign in Chennai. And here this network I'm going to assign in Kolkata. Got it? Very simple. Now, yeah. So now how I'm going to assign IP addresses in Delhi? So when we are going to assign IP addresses in Delhi office, or maybe the servers in Delhi, what, how I'm going to give the IP address in computer? How we write this 26 in computer? Because 24 is very easy. We can write 255.255.255.0. So this is 24. But how I'm going to write 26? I'm going to show you. You have written down all this. Can I move ahead? Can I remove this? Okay. Yeah. See, understand subnet mask. So by default, we get subnet mask 255.0.0.0. If your slash value is 9, how you are going to add here? So again, that thing comes with the to the powers. So your one network will be represented with the powers. So you have every block is like this. So this block also, this block also, this block also. So in the first block, if you have 8, so it means 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is first portion, and you get 255. Right? So 8, right? 255. So when we have 9, so what we have, so in the first group we have 8 plus 9, so again 1. So rest all zeros. Right? So 255, and here above 1 we get to 128. So that means 128. So it means we will have 255.128.0. So when we say 10, what will happen? So when we are going to solve for 10, so that means 8, this covers 8, and here we need to add 1 here. So this is 255, and just plus these two values on top of a 128.64, that comes 192. So in here we are going to get 255.192.0.0. So I'll give a very simple formula. You don't have to calculate every time. So whenever anything, when we add one bit, you always add 128. When we get two, 192. So when we have three network, three ones, we always get 224. For 4 bits, we get 240. So for 5 bits, we get 248. For 6 bits, we get always 252. For 7, we get 254. And for 8, always we get 255. Just write this and you will understand subnet mask. Now, if I'm calculating for slash 14, what you will do, 8 plus 6 is 14, right? And you know always 8 means 255 and 6 means 252.0.0. Let's slash 19. How you calculate 19? 8 plus 8, 16, 16 plus 3. So 255, 255, and 3 means 224.0. Just write this one. So what was the value we got in last question? Slash 26. So 8 plus 8 plus 8, 24 plus 2. So that means 3255. And for 2, we get 192. So in our last question, all computers in my Delhi location will have this subnet mask. Okay, cool. Hmm. So you can solve this for B also, A also, like that. Okay. So guys, let's take 5 minutes break. Okay, and I'll come back. Okay, hi. So guys, we are going to do one practical now. Okay, so what I'm going to do, I'm going to connect one router with one network. Okay, maybe I have one or two PC here. Okay, and here also I have another PC. So if my computer IP address is 192.168.1.1 or maybe 1.11, and here I have 192.168.2.11. So tell me if they are able to communicate if I have cable like that. Just forget we have router. So tell me if they are able to communicate. No, right? So we need a device which actually connects two different network, and that device is known as router. So we are going to connect a cable with this router, and when we add a cable in this device, so we need to give IP address here also. So we can give the same IP address where we have this network 192.168.1.1. I am going to give here, and here in another link, this is a separate link in router. Here I have to give 192.168.2.1. So it means a router will have two IP address, So this is the work of routers to connect different networks. To connect different networks, we use this device. Okay, and computer will have subnet mask by default 255.255.0, and computer always have a default gateway. What is gateway? Exit point of LAN is known as gateway. So I'm going to assign 1.1. So that is my router IP, because if computer wants to go outside the network, they are going to use this is gateway for that LAN network. Means when you, this is your home or something, right? So suppose, and you want to go outside, so you always use the gate, right? So that you can exit and you can enter from this gate. So it's like that. So router IP address is like working as a gateway for you. So this is my gateway, because to connect with the different network, I'm going to use the router IP as my gateway. Okay, so somebody asked me, like, so what is the difference between gateway and router? So router is a device, that is hardware, and router can have multiple gateways for each LAN. So this device will have this IP address as a gateway, and for this computer, this IP address will work as a gateway. Just exit point of the LAN, exit point of the LAN is known as gateway. Okay. So let's go and create a lab. So I'm going inside racks with 8086. Hmm. So I'm going to create a lab. So I'll name it router lab. Okay. So here I'm going to add a device. Let's take this device. So this will work as, so I have router. So I have two switches and I have two machines. So the same lab you can do in your lab access like this. Okay. So, okay. So this is the lab. So I'm going to start this router. And before doing this, I'm going to type here the IP address I'm going to use 192.168.1.1. Here I'm going to use 192.168.1.1. And at the below machine, I'm going to assign 192.168.1.11. On the another side of router, I'm going to use 192.168.2.1, and here I'm going to have another IP, that is 192.168.2.2. Okay, so from more action, start all devices. Okay, so my all devices are up. Okay, so I'll open this router. Okay, so this is my router. So I'll always say no in the configuration. Okay, so we will assign two IP address and you can see there FA01. So what is this? I'll show you. So once you log in into your router, you are into by default which mode? User mode. And which what is the command to enter further mode? Enable. So once we are, so this mode is known as privilege mode and this mode is user mode. Okay. So router, when you this see this prompt, this is known as user mode. And when you see this prompt, this is privilege mode. And when you see a bracket on top of this router, so this we call global configuration mode. Okay, clear? So I'm going to create a lab here so that you can do this. Okay, so what I'm going to do, I'm going to type the commands over here so that you can write the commands. So first of all, I need to enable the device. Then I have to go configure terminal. So this is the command to go into my global configuration mode. Configure terminal. Okay, so now you are into global configuration mode. So after that, if I want to change the device name, so what is the command? Host name. So my router name is router, so I can name it NW Kings or something. So I will write host name NW King. So you can see you don't have to commit anything directly. The things are changing here. Okay. So in advanced routers or maybe if you work in Cisco ASR or big series or even in Juniper and all, so you need to save the things uh, to enable the changes. But in Cisco normal devices, whenever you do any change, it will not ask for to save the configuration to do the changes. So whenever you type any command, it automatically changes. Means I have given a command host name nwkings and you can see the prompt here nwkings, right? So now I want to give IP address to this router. So this is an interface. What is this? This is an interface. So I will type interface. Router ports are known as interface. Interface FA0/1. So you can see FA01. So I will type interface FA01. Harshika, that's in Cisco. It's like that only. This is the reason we love Junos. Okay. So interface FA01, IP address 192.168.1.1 and with subnet mask. Just check here guys. I'm giving IP address and then subnet mask. Just click enter and you need to give a command no shutdown here. So why we are giving this no shutdown command? So that we are going to enable this port. Okay, this is like enable, disable your port. No shutdown is a command to enable the device port. So IP address 192.168.1.1, 255.255.0, no shutdown. Okay. So tell me what would be the command for next giving IP address to another interface that is FA00. Just type in the chat. Hmm. Yes, correct. I need to go inside again. Interface FA00. Okay, IP address 192.168.2.1 3 times 255, and again no shutdown, right? So the same way you are going to give the command interface FA00, and I'm going to type 192.168.2.1 and click on no shutdown, and your IP. So you can see some messages here. You can see here change state to up. So it means the interfaces are up now. And how to check my interfaces are up or not? You need to go back into privilege mode. So how to go back directly to privilege level? You can just type end, END, or you can give exit 2 times. I'm giving end. So directly I'm into privilege mode. So now I'm going to type show IP interface brief. This is the command to check if I have given the correct IP addresses or not. So tell me if I have given the correct IP addresses. Okay, so router makes a table that is known as routing table. What is the command to check routing table? Show IP route. So there you can see a lot of codes that is for different protocols like EIGRP, OSPF, RIP and all. But as of now, we are not connecting multiple routers. We are working on one router, and both the networks are connected to my router, and it is showing you my 192.168.1.0. But I have given IP 192.168.1.1. But why this is showing me 1.0? Because router only saves network IDs. So what are network IDs? So network ID is like house of IPs. Like, see, I have one computer, maybe you have 100 computers. So router would not save 100 computer IPs in its routing table. It only saves the house of IP address. Or you can say that network ID in networking terminology. Network ID means all IP belongs to this network. Because when we will have another router, okay, when we will have another router here. Yeah, so when router is going to connect with another device further, so router is going to share not 100 computers IP address. Instead of sharing, it is going to share only this network to this router, and router will have 192.168.1.0. And we have another network, maybe you have one IP, or maybe you have 100 IPs or 100 computers here. So router is going to send 192.168 in 2.0. So instead of sending all host IP addresses, I'm going to send my network IDs. So these are known as network IDs. So that means house of IPs. So that term you can't use it. This is just for your understanding. But in interviews or somewhere, you can always say network IDs. Why we using default subnetting? Because this is the first practical of a router, and I don't want a confusion, right? So that you will get confused. So let's go and give the IP addresses to computer, right? So very easy. Just open the computers in your lab. So somebody was asking me what is the password. I have given the information. Windows test 123, test 123, but the first T is in uppercase. Okay, test 123. So in my first computer, I need to go under ncpa.cpl, and here I need to give in properties what would be the IP address 192.168.1.11, and my subnet mask is 255.255.255.0, and gateway would be router IP 192.168.1.1. So once I assign this IP, what is the best thing? Bus ping 192.168.1.1. So you can see a ping from router now. So you are pinging your gateway. This IP I have given to my gateway. So in another PC, ncpa.cpl, inside my, so what would be the IP? 192.168.2.11, right? So IP address would be 192.168.2.1. So so let's test the connectivity from PC2 to PC3. So what would be the IP address of PC2? 192.168.2.11, right? So let's see. So here we go. You can see we have connected two different networks, guys. How much IP we can assign to router? It's better to always have IPs when you have multiple interfaces. So it depends on the router model. So we have very big routers where we can get around 100 plus ports also. So it depends actually. The practical is successfully completed. We are able to communicate from PC2 to PC3. So again, I have shown you that I am pinging to 2.11. So, but my computer IP is 192.168.1.11. And you can ping 2.11. Yes, I'm able to ping this. Okay, cool. How to check the, okay, how to check the assigned PC IP from router. Okay, so I'll explain tomorrow this ARP. Okay, so tomorrow is very important class to understand ARP. I'm going to explain the packet flow. Okay, so tomorrow is very important. So, so I'm going to explain ARP, packet flow, and we will see what is, we will configure DHCP on this device, and we will also configure telnet. So tomorrow topics will be ARP, packet flow, DHCP, and telnet. Okay. And guys, are you really loving these classes? Is this a good initiative from networkings or from my side? What do you think? Because I'm little worried that almost 350 plus candidates registered, and only 70 to 60, or maybe sometimes some guys come. Yeah, so some are coming or going. I don't know what is happening. Maybe this is okay. Okay, so because I thought if students won't come, then it's better to have like 3 sessions. But you guys are giving me boost, and I'll have another session tomorrow, and we will try to complete those 5 days as committed. Kunal, so what do Kunal is asking, sir? We can have 100 interfaces on router. Yes, it depends on the model number. This router may have around 4 ports or maybe 8 ports. Okay. So it depends on the model number. You can always check Cisco or Juniper or any company name. So let me show you Cisco routers. So just go and check the cisco.com, and there are multiple. So you can see a branch routers that is ISR 4000 series. So if I go on ISR 4000 series, so you can see, so every device have a data sheets. If you want to learn about the device information, because if you complete CCNA, CCNP or anything, or maybe JNCIA, different certifications, most of the most of the interviews you are going to attend, they might ask you on which devices you have worked on. So you should have a basic understanding about the devices and how to get those basic understanding. So just keep on checking the data sheets. So how to check the data sheets? So on every device, you can just search for the data sheets. Maybe inside this. Yeah, see products. Yeah, so you can see a lot of model numbers here. Okay, and they're doing, so you can check the model number like Cisco 4000 data sheet. Okay, so that is a data sheet, and you can check Cisco 4000 series has that many model numbers, and they can support these many technologies. Okay, so they also support the Cisco latest technologies, that is Cisco DNA, digital network architecture, and how much throughput means how much maximum speed you will get on these devices up to 2 Gbps. And if you have, yeah, current software services at speed up to 2 Gbps. Okay, so it has integrated SD-WAN solution also. SD-WAN is a very new technology, recently introduced in last 1 or 2 years, getting very much popular, and most of the companies are moving to SD-WAN. AWS technology, discrete network industry. No, Lokesh, it's just a, see, what is the, so let's discuss about the career path now. So what should you like, how we can start, or how should you go and further? Yeah, so to become a good engineer, so the basic, the minimum things I'm telling you. So you can start with CCNA, okay, and or maybe you can start with the JNCIA also, okay, but it's always go better to go with CCNA, because it has the Cisco study or Cisco books or Cisco content is better, I would say. Even worked for both the organizations. So CCNA, you can start. You can learn Juniper things after CCNA. So it's better to go CCNA first. So CCNA JNCA is both equivalent. Okay. So I'll write here CCNA only. So you can start with CCNA, and further you can go for CCNP. So that will actually add on a lot of technologies like BGP. You will learn MPLS. So you will learn advanced things like DMVPN. You will learn IPsec. So there are a lot of technologies here you will understand in CCNP. And after that, see, every company I have seen on Naukri.com, I have seen on LinkedIn, every company needs firewall nowadays. So it's better to learn firewalls. So I only recommend these three things to any engineer, because you will not restrict yourself. So I'm giving you one example. Uh, Trust me, this is very important. So suppose I worked for Cisco TAC for almost 3 years. So I'm very good in Cisco, but outside Cisco, I don't know anything. So if I'm looking for a job, I can only go in a TAC profile. I cannot go into enterprise, right? So it's better to always learn multiple technologies so that you will be ready. Yeah, you will get only support jobs or tag jobs, so it's better to have CCNP firewalls. Okay, and once you learn this, Then go with the little bit programming stuff, that is like Python for network engineering. You don't have to learn Python, which is actually making websites. You just need to learn Python, which is for network engineers. Which firewalls to learn? So there are many firewalls like Palo Alto. Palo Alto is very important nowadays because every company is using Palo Alto. I'm just giving example. So I used to work with Apple and they have Palo Alto firewalls. So they have Juniper SRX firewalls also, but they have replaced Juniper to Palo Alto now. Okay. So once you complete this, I think it will take maximum 1 year and you will be having the same knowledge what 10 years experience guys have in industry. So if you have Pix firewall is obsolete. Yeah, so if you have 1 year, 2 year, 3 year experience, trust me, if you learn these four things, you will be ready like you have 10 years experience, because even 10 years experience guys have up to this type of knowledge. But you need to make sure that you will learn in a very good manner. You will not only do these courses just for the sake of completion. Yeah, okay. So firewalls like Palo Alto, Checkpoint, and there is one device called F5 load balancer. So like that you can go for this, and once you complete this, then you can go with the cloud technologies. So I would recommend fifth point, VMware VCP. That is for to understand the virtualization. So it's optional. This is optional if you want to learn, because if you learn this, you will understand virtualization. And every, why I'm telling you this, because for one reason, because all cloud works on virtualization. So if you understand virtualization concepts very deep, then you go for AWS or maybe Azure. Okay, so any cloud. And then seventh point, take or you can note down my things what I'm telling you. This is the future. So that is AWS Azure cloud migration. Cloud migration means companies are actually moving to cloud. You are going to configure in this course, you will configure router, you will configure firewalls, but you will be going to configure in cloud. Here you are learning what exactly is the cloud, right? You will learn how AWS works, how Azure works. But in AWS Azure cloud migration, you will configure routers, firewalls, and a lot of other devices in a cloud. Okay. So VCP is optional, SD-WAN also optional. So if you want a little more boost, you can go for like SD-WAN before. Like that is SD-WAN you can learn here, or you can go for like this. Amar, VMware network NSX is not required because VCP or something. If you learn this, so automatically you can say that you are getting that type of knowledge. So this is, see this, you are learning firewalls here, man. So directly you are going to network security, means you are a net, you will be a network ninja. Okay. So you can be a network consultant for many companies. You can do freelancing also. Okay. What does freelancing means? Means you can take projects from lot of websites are there like Upwork and all. So, but yes, it's better to get freelancing projects, but never use your company laptops. Okay. I have seen many guys got, yeah. So if you want to learn Azure, then there is no use of directly learning Azure. So it's better to always learn network fundamentals. And what is the best way to learn Azure? Because Azure is Microsoft oriented. So there is a course named as MCSA. So you can directly go with MCSA and Azure also if you want to become a system engineer. So this career guidance I'm giving for Network Ninja. Okay, and maybe after 6 months I will do some changes, but for next at least for 5 6 years, this is the best thing. So you can start with NA. See, if you don't have job right now, you are jobless. So we made a plan that is known as CCNA, MCSA, Linux. So that is a very basic, like to become a network engineer, to become a system engineer, to become a Linux administrator. So it's a combo. We call this phase one in networkings. So if you don't have job, directly go with this plan, because if you learn only CCNA or you will do CCNP, actually you are learning a lot many advanced courses. But if you don't have job, it's better to learn the associate level courses so that you will at least find the correct job for yourself. Okay, if you are a fresher, so by learning this CCNA MCSA Linux, you can apply for network engineer, system engineer, or Linux engineer. So that is the best course in the market right now to get into IT right now. Yeah, so you can contact team, or I'll share the link with you later on. Linux takes approx 20 days. We cover this courses in 45 to 50 hours. So you can check this website. Okay. So we have made our website with the career guidance also, like go to nwkings.com. So here you can see all the career guidance by default. Okay, so this we design for working professionals and for freshers also. Okay, so choose your career. So we are actually training students on four different technologies or four profiles: network, system, security, and cloud. So if you want to become a cyber security engineer, so phase one is default for all. But if you are already working, like if you have 2 years, 3 years, 4 years experience, then you don't have to learn MCSA Linux. You can directly jump to CCNA and CCNP. But if you don't have job, then go and start with phase one program. So which is a combo of CCNA, MCSA Linux. So these courses are actually designed by all like engineers. So we are a company which actually all our instructors are working professionals. So like the person who is taking MCSA or maybe the person who is taking Linux, they are actually working as a Linux administrator or maybe system engineer. Okay. Preeti, I would recommend you to go with CCNP first, then learn Palo Alto, PCNSC. Because Palo Alto, because you are see, security is like add-on. Suppose what I'm trying to say, you need to learn the basic first. It's like a pizza, right? So like if you want to eat a pizza, you need to have a good base, right? Then you can add all add-ons like cheese or maybe olives, anything. So these olives or maybe mushrooms or anything, I'm getting hungry for okay, so these all are add-ons. So add-ons means like you will learn like Palo Alto is add-on. Okay, like checkpoint is add-on. But what is the base? So base is for a fresher, like base is to learn multiple things so that you will get entry in job. So base could be like this, or base could be like CCNA, CCNP. Okay. So either you can make a base from this. This is white bread. This is brown bread. So you can use any of the base. So once you get entry, you can keep adding the add-ons like Palo Alto, Checkpoint, SD-WAN, or like any further technologies like VMware, Python. So all these are add-ons. But if you just keep learning the add-ons, but if you don't have good base, then what you are eating? You are just eating the vegetables, man. You are not eating a pizza. I hope you are getting now and you are understanding the things. Okay. Yeah, Binav, you can go with the CCNP. See, Preeti, don't stop learning PCNSC. You can start with NP because it will help you to understand BGP MPLS in detail. Our certification is important in industry, and what is a global certification? Yes, actually certification help you to boost your career. Certification is like a booster. You have played a game called Need for Speed, right? Maybe, or you have seen it. So you are doing a car race, but sometime you want to just enable the nitrogen to boost your career, right? So certifications are like that. It's like boosters. Okay. So it's like boosters. So by learning new things daily, you are actually growing, right? You are growing. But if you have very good knowledge, but still you are not growing, then just add the booster. Boom. Then you will get more jump. Okay. It means first focus on growing, means focus on growing. How you get keep growing in the industry? You by learning new things, by learning. So certification is needed when actually you have enough knowledge. Are you getting now? when when you have enough knowledge to boost. Suppose you don't have knowledge and you just get the certification done. You don't have knowledge, you get do the certification, you will be like this, completely plain. But if you have good knowledge, then you will be like this, and booster is like that. Okay. So means knowledge plus certification is good to go, but if you don't focus on learning, just keep doing certification, then there is no use. This is just a paper. Learning plus certification. Sir, can a fresher enter in industry with only CCNA knowledge? Yes, but as I told you, if you don't have job and you only do CCNA, so you can only apply the jobs related to CCNA like network engineer. And might be a chance you will not find it in 1 month or 2 months. Maybe it will take time, but yes, within 3 to 6 months, or maybe it's your luck, maybe after a month also. It depends on your learning and how you give the interviews. So many guys do CCN and get the job. Okay. But if you really want to, if you are needy, or you really want job as soon as possible, then again I told you, then you need to learn multiple technologies like CCNA. MCSA will train you Windows servers, Linux will train you for Linux commands and all. So for freshers I recommend this, because I know from fresher point of view, our main focus is to get a job first. So once we will have around 3 to 5 lakhs, or 3 to 4 5 6 lakhs package, or let's take 3 to 5, okay, then it's good to go with the different things. Sir, can fresher get 3 to 4 lakh package? Man, it depends again from where you have done your studies. I have seen freshers are getting 9 to 10 lakhs even.
Hi, you are watching the recording from one of our live session. Hit like, share, and subscribe for more future updates.
So in last 3 days, what we have done, and if you have not seen my last three classes, you can check our YouTube channel Networkings, or you'll be getting an email very soon also. Okay. So Yeah, so today is day 4. So in last 3 days, what we have covered the network fundamentals. We have covered OSI model, which is like open system interconnection, and we have covered some part of subnetting, and also additionally we have done some basic practical. I had I have checked with my team, almost like we have created 400 user names and password for lab access, but it's maybe students or few guys are not interested. They are getting free lab access, they are not paying anything, but still they are, maybe I think that is the reason. If till the time we don't pay for anything, we don't value it. So maybe that is the reason. But yes, we have already created a lab access for everyone. We have shared the details on email also, how to access the lab. Okay. So, but yes, we are giving that lab access till 31st. If you want to use that and really want to do some basic practicals, you can still access that lab. Yesterday videos and all, like we have shared the email, and additionally you can check our YouTube channel where we have shared all the links. So I'll show you how to access that. I'll share one link with you also. So we are creating notes where we are putting all the details. So you can see day 1 recording, day 2, and I'm going to add the third link over here. That is yesterday class. Okay, that is the third video. Okay. Yeah. So this is third video link. So how to access the lab? You need to go on this website, racks.nwkings.com/8086. Okay. So you need to enter your username, suppose, yeah, and you need to log in. Okay. So as of now, if I'll check, maybe few guys are doing lab or maybe not. But yes, we have created for almost 400 plus users. Like we got a list. In that list, we almost created a lot of accounts. Okay. Yeah. So that is the list. We got around 564 candidates registered for these lab access classes, but most, like only 10-20% are attending the Zoom sessions. But maybe due to lack of time or something. So these all accounts we have created. Okay. So I don't know they are using it or not, but we are, that will be going to expire on 31st of December. Okay. Yeah. So let's start. So like I have created 3 labs here. You can do a basic practical. So today we are going to do another lab also, where I'm going to explain you like how to connect multiple different locations. And okay. So yesterday we discussed, I'm going to explain you today what is ARP. Okay, so we will discuss now ARP, and after that I'm going to explain you about the packet flow, and third thing we are going to discuss DHCP, and fourth thing we are going to discuss Telnet today. So are you guys ready? Just say yes in the chat. Okay, good. How can access? These are not PPTs. These are my notes which we have created for you. So I'm going to share link in the, just check the link in the chat. I have shared the link. So all details are mentioned here also. Okay. And you will be getting one email also if you want to join, or like if you want to join my CCNA batch, which is starting from 11th. And I'm going to start one CCNP batch also, that is from 9th Jan. Okay, that details I'll share in the email. Okay, so keep checking your email. That comes might be with some discount. Okay, so let's go ahead. Yeah, you need to always use HTML console. Native console will not work. Only use HTML console. So when you log in, right? So there are two options: HTML console, native. You have to use HTML console. Native, we have blocked the ports. Okay. So what is ARP? What is ARP? So ARP stands for Address Resolution Protocol. Okay. So Address Resolution Protocol. So I'll give you one example. Like if I have one computer A here and B on the another side. So like my computer will have one IP 1.1.1 and B will have 1.1.1.2, right? So if they are connected together, and in this computer you are going to type in the command prompt ping 1.1.1.2. So why we are doing this? Because we want to confirm if this device is connected to me or not. So ping actually means I'm going to send some messages to this router, so sorry, to this PC, so that PC will reply back, right? So I'll get replies. But what is ARP? When we send data to anybody, we need MAC address of that device also. Okay, so if I'm sending a data to 1.1.2, so I need a MAC address of this device. So by default, my computer does MAC address. So this computer will not have. So every computer, like it's a Windows or Linux or something, they have ARP table, ARP table. So what you will see in ARP table, you will see all MAC address against with the IP. So suppose this IP is 1.1.2. So computer A is going to store the MAC address with the corresponding BB. Suppose this is MAC address of B computer and this is for A computer. Okay. So if I want to send a ping packet to this device, I need MAC address of this device first. Okay. I'll explain again. So computer A has a IP 1.1.1 and computer A has a MAC address AA. So computer A will have a table that is known as ARP table, Address Resolution Protocol table. So whenever we send data to anybody, we need a MAC address for that device. So if my ARP table have no ARP entries, it means if I don't have any entries, what will happen? I'm going to shoot out a ARP broadcast packet. ARP broadcast packet, and I'm going to ask who is. So I'm going to ask who is 1.1.1.2. Okay. So whenever you send a ping packet or anything to 1.1.2, so the ping packet will be on hold. I'm going to say just hold the packet before I send data. Let me check if I have MAC address of that device. So if I want to send any data to this device, what I'm going to do first, I'm going to check if I have the MAC address of 1.1.2, but sadly I don't have MAC address of 1.1.2. And if I don't have MAC address, what I'm going to do, I'm going to send ARP packet first before sending data to get the MAC address. So I'm going to send a ARP request. Please give me your MAC address, and B will send. B is going to respond with his MAC address, and we are going to store that into our ARP table. So once we have the MAC address with the correspondence IP, then I'm going to send data. So till the time you don't have ARP entry, the machines don't send data to the device. Clear? Yes or no? Okay, great. Okay, and this is the story of two computers, but when I'm going to connect with a router, suppose like this scenario, what will happen? If I want to go from 1.1.1 to 7.1.1.1, what will happen? This computer does not have MAC address of 7.1.1, right? So this computer will not have 7.1 MAC. Then I'm going to send information with the help of router to another network, because router is a device to connect with the different network, and this network is in different network. So I'm going to get the MAC address of my gateway. What is the gateway? The router IP is known as gateway. So instead of getting the ARP entry for different network device, so my computer will have ARP request, or my computer is going to send ARP to my router to get the MAC address of router. So instead of saving different network MAC address, I'm going to save the MAC entry for 1.1.100 and corresponding MAC address, like suppose double C, like that. Because I will only have my LAN network IPs or my gateways MAC address in my ARP table, because like if you want to connect different network, you need a router. Okay, and router does not forward the broadcast packet, and ARP packet is a broadcast packet. So if you are going to send a ARP message, router is not going to forward to another network, because router stop broadcast. So if we can't send ARP or broadcast packet to outside network, then router is going to respond with his MAC address. So I will only have MAC address of my router. Very good question, Rajat. Rajat is asking how computer will understand if another device is in my network or different network. I'll explain. Okay, that is known as ending process. Okay, I'll explain this. Okay, so ARP is clear. Connect audio. Ashik. So let me show you one practical. Okay, so let me turn on my two machines again, and let's see if both the computers are understanding the MAC address of each other or not. Okay, so my two machines are here. Yes, yes, Harshika. Like the ARP table we have of computers, we have ARP table of PCs and routers also. Even router is like a computer only. Router is just like a computer, it has RAM, the storage capacity. So all most of the things are similar, but router is actually meant for to connect different networks. Okay, so my both the PCs are here, and let me check if I have given any IP. I don't think so. We have given any IP address. So let me give any IP address 1111. Okay. So in another PC, see from my last 11 years experience, trust me guys, there are many guys who actually come for interview, but it's not like that. They don't have very advanced knowledge. Actually, the problem, they are not getting selected in interviews because of their network fundamentals knowledge. They lack network basic knowledge. They don't know OSI model. They don't know TCP three handshake and all. So to get a job, you don't have to be expert. If you know the basic also, you can still try and get a job. Okay. So rather than becoming a network ninja before learning expert courses, you should be very good in network basics. Like one guy asked me with this question just now, Rajat Mittal, sir, how computer identifies if the network, if another device is in my network or not? So if you don't know this, it means you will not crack very good interviews. Actually, it's a process of ending, so I'm going to explain it today. Cisco IOS is developed on Unix or Linux. It's a Linux based operating system. Yeah, fundamentals never change. Okay, so I have given the IP address. Let's go on CMD and I'm going to type first. Let's see ARP table, ARP hyphen A. So I'm getting automatically this computer is getting 1.1. Let me delete this ARP hyphen D. Okay, ARP hyphen D is to clear your ARP table. So ARP hyphen 8 means my computer does not have any MAC address. So whenever I am going to send 1.1.2 any packet to 1.1.2, so what will happen? Like whenever we send data, actually the network is very fast. You don't see any drops, right? Because it's a LAN network. So actually my device sends a ARP request first and get the MAC address of 1.1.2. You can see the MAC address is already in my ARP table before sending this ping packet. Or you, whenever we send data, so the data will be on hold. Computer is going to ARP first, and ARP will get the MAC address of another device. Then I'm going to send data. Okay, so means we need MAC address of the same device where we are going to. If this computer is going to 1.1.2, I need MAC address here. Okay, so you can see this entry is dynamic, means the computer is generated this MAC address or got this MAC address automatically. This is not a manual entry. Okay, but yes, you can do a ARP in Windows. You can do a static entry also like ARP hyphen S 1.1.1.2. And what would be the MAC address? Let me take from here. 50. Yeah. So, so this is giving me one error access deny because maybe I have not. Uh, I need to run as administrator or something. Let me do that. So CMD. So I'll do it run as administrator, paste. The ARP entry edition field access net. Maybe it's already there. This is the reason. Yeah, now it's taken, right? So let's check now ARP-A. So you can see this is a static entry. So my computer will only listen this MAC address or only send the information to this MAC address. Okay. It's a good way if you don't want ARP broadcast. Okay. Yes. Got it. So in Windows, there are a lot of commands, guys. Like if you learn this CLI, so it will help. So So in Windows, you can give the command with like if you want to assign IP address, so you can give the name also, or you can assign the IP address from commands also. Like there is a command called netsh. So netsh. So you can see I'm inside netsh, and here I can give the IP address. So netsh interface like that. IPv4 set address name. So my interface name is, I think. So what is the command? My net interface name is. I think this is the interface name. Yeah. So this is my interface name. So this is how you give actually IP address. You can Google it and learn about the netsh. So I remember I used to give IP address with the command also. So right now, so this is just to have more knowledge, nothing else. We know how to give IP address, so that is also enough. And if you want to give IP from here, you can also give IP from here also. Okay. So we have cleared the. Okay. So this is all about ARP. You can check there, like you can just type netsh hyphen help, and it will show you what are the commands used for. Okay. So now we are going to do a lab again. So in this lab, I'm going to add 4 routers. So this lab will be known as static routing. Okay. So I'm going to do a lab for static routing. So in this, what we are going to do, we are going to take 2 routers. Okay. So these are my 2 offices. Okay. So you can just take an example of these are my 2 branches or 2 offices. So I'm taking 2 switches here. So in the yesterday practical, we had only 1 router, but here you can see I have 2 routers. Okay, so let me add here one Linux machine. Let me check if this Linux machine works or not. Yeah, so this Linux machine is working fine, and we can give IP from here. Or yeah, so this IP is showing me. So we have not given any IP to this Linux machine. So I'm adding one basic Linux machine over here so that you can run few commands for Linux also. Okay. See, we need to learn multiple technologies. So real networks are mix. We can't stick to only router and switches. We need to learn a few other things, and Linux is very important for even network engineers. So when you will be with any good company, they actually get the logs on Linux machines. So we need to find the logs with the Linux machines. So that is the use of Linux. If you are asking me why we need Linux or why we want to learn Linux or Linux, whatever you want to say. Okay, so this is my topology. Looks good. Yes, guys, it's visible. Okay, okay. So what I'm going to do, I'm going to divide one network into two parts because we have learned basic subnetting. So suppose we have a network that is 192. We have a network 192, 168. Okay. So we have a network 192.168 1.0/24, and I want to divide this network into two parts. So what exactly I have to do? So I have total network bits and host bits. So total I have 24 and host is. And if you don't know this, just check my third day video. I have already shared the link. Okay. So host is 8, right? So how many networks we want from this network? We want two networks. So if we want two networks, how we get two? When we take 2 the power of 1, right? So just check the power. So we want to divide into two parts. So how we get 2? When we say 2 the power of 1, then it's 2, right? If I want to divide this network into four parts, then I will have 2 the power of 2. So we need to check the 2. We always keep checking the power. So here I got the power 1. So what I'm going to do, I'm going to reduce 1 here and I'm going to plus 1 here. Okay, because I need more networks. So this will be 25 and this will be 7. Cool. So now this 7 means 2 the power of 7 is 128. So my network will divide 0, 128. It will go 255 and before 128 we get 127. So these will be my two networks. Super easy. Yes or no? Okay. So I will have 192.168.1.0/25. Okay. And don't worry if you don't know this, you can keep checking the old videos. And so here I'm going to give, see, we have two groups here. So 0 we can't give because this is the first IP. This first IP is known as network ID. So I'm going to assign 1. So I will write 1 here, and from this block I will write either 129, or you can take a round figure here also, like 200, because 200 IP is from this group and one IP address is from this group. Okay. So I'm going to write here 192.168.1.200. Okay. So these are two different networks. So why we have done subnetting? Because we want to give to our two locations. If we will not do subnetting, we have to use different network. Okay. So between these two routers, I need one another network. Okay. So maybe I'll use, let's take basic one. So I'll not, so let's take another network. So I'm going to take here 200.1.1.1, and here I'm going to take 200.1.1.2. Okay. So below you can see my window machine. I'm going to assign here 192.168.1 dot. Let's take 1.2, because here I'm going to give 192.168.1.1, and below here I'm going to use 201. Okay, and this Linux machine I'm using first time, maybe it's based on different IP. Let's check how to give IP to this machine. Okay, so let me turn on more action, start all nodes. So all of my devices are almost ready. Okay, so are you ready with the are okay? Okay, let's start. Yeah, so let's count on uh, why I'm not able to type, just hold on. Yeah, got it. So we have three networks. One is this. So one, we have this network. Another is this one. Sorry, what is, yeah. So one first network, second network, and third network. So we have three networks. So first, second, third. So remember always, like when you connect routers, so router ports facing each other should be in same network. Okay. So when we connect two computers with each other, they should be in same network, then only they speak. So it goes with the router also. When we connect two routers facing each other, should be in same network. Okay. So here I'm going to assign IP address, and then we are going to assign the IP address on Windows computer. So let me start router 1. So this is my router 1. So remember always we need to do no here. So now we are inside router. Why we always say no here? Because it is asking me if I want to do some automatic configuration or not. So just in a short, like in a simple language, I can say that if you really want to become a network engineer, always say no. Yes is for those guys who are like very beginner. Okay, if you want, router will set up all the configuration for you. So always say no so that you can type the commands. Okay. So this is my lab. Let me take a screenshot. So this is my lab. Okay, so I'm going to type the configuration here. So what would be the commands? So this is a notepad. Okay, this is a software which I'm using for my notes. That is a Notion. So you can use it for free. Okay, so that is, I'm first of all to go inside the router, I need to type one command, that is enable. So I'll show you here also the commands, and I'm going to type the notes for you. So enable. So once you go enable, you need to type configure terminal. This is the second command to go to the upper level. So that I have already discussed, I think, in second day videos. So now we are inside router global configuration. So we can change the router name, host name R1, host name R1. So you can see we have R1 now, and you can see I have two interfaces. One is FA00, if you can see here, if it's visible to you. So FA00, that is fast Ethernet 00. It's a port where my switch is connected, and FA01, that is another port. So inside my FA00, I need to give IP address. What is the command? IP address 192.168.1.1, 255.255.255. By default it's 0, but we have done subnetting. And what is the subnet mask of /25? 255.255.255.128. If you don't know this, just watch yesterday video. Means you need to learn all three sessions, then only you will understand day 4 also. If you are skipping those sessions, might be you will not understand. So no shutdown. Okay, and on FA01 I need to give 200.1.1. So in interface FA01, IP address 200.1.1.1, no shutdown. So we here I am not doing any subnetting. So tell me guys if you have any problem in this. I'll share a Notion link, don't worry. So interface FA00, IP address 192.168.1.1. Okay, cool. Let's give IP on another router also. So I'm going to make a duplicate of this, and I'm going to just add here. So here I'm going to type for R2. On R2, FA00 is 200.0.1.1.2, and on FA01 I'm going to have what IP? I'm going to have 1.200. Rest all commands are same. So just I have changed the IP address, changed the host name, and rest all things are same. Okay, so let's go to router 2 now. So this is router 2, and I'm going to say no. So give yourself a score out of 10. If you understand whole, just type 10. And if you understanding a little bit, just give 3, 4 score to yourself. Okay, great. Okay, don't worry. I have already shared this. I'm going to share this link again with you. Just watch these 3 videos first and you will understand, and you will also get 10 out of 10. Okay. Chintan ji, you are watching from day 1 and you are still saying 10. Sorry, no, 8. You need to keep revise the things. Okay. Rahul, you are my old student, man. I remember you, right? So how? Okay, Adnan, don't worry. Okay. Okay, so we have given IP address and let's go with config T. Okay, host name R2, interface F01, IP address 192.168.1.200. If you don't understand, just copy it. First time you do practical by just checking the notes, and after that try to implement from your own. Okay. You know what is the best thing about learning networking? Like you are doing something, and if you do something, it actually motivates you, that it actually rewards you that you are doing something, and when the practical gets successful, na, so it motivates you to do more and more. So whenever anybody thinks that we will only check the books, we will only check the videos, or you will learn the by videos, it is not going to work for you. In this IT, when you do it, then actually you get motivated to learn more. Okay. So rather than just learning, learn with by doing it. Okay. So we have given IP address R1 and R2, right? So tell me, let me give IP address to my machines now, and let's check if they will ping each other or not. So what do you think? Without doing anything, are they going to ping each other, or we need to do something routing or something? 192.168.1.2. So we want this computer to connect with the gateway. So let's test if my gateway is pinging 192.168.1.1. So you can see I'm getting a reply from my gateway. And let's try to ping the another router, which is like 200.1.1.2. We are unable to ping that router IP. It means your ping, so it means your ping is going from here to here, but this router is not responding. Why? Why my computer or my router is not responding? Okay, so if I'm pinging to this IP address, this router is not replying me. You can see ping is getting drop. So you can see requested timeout. Requested timeout comes when your destination is not replying you back. Most of the times this is the issue. Okay. Why we are getting this? Because we don't have route to the destination. What does it mean? When you send any information to this router, and which IP I am going to, my source is 192.168.1.2, and router 2 does not have this IP information. This router does not have any information. So let's check our router. So let's go to router 2 and check one command, show IP route 192.168.1.2. So what exactly router is showing me this? Show IP subnet not in table. It means 1.2 is not having any route. To reach 192.168.1.2, I don't have any route. Okay. So this is the problem. So here what we have to do, because remember this term that router only have its directly connected information. It means router will only have its links information. So if router 1 is connected with this link and this link, so router 1 will have only these two networks in the routing table. Let's test. So let me go to R1 and let's check with the command show IP route. So can you see I have only two networks, 192.168.1.0/25. Sorry, this is R2. Yeah, so let me check here. Show show IP route. Yeah, guys. So you can see I have only two networks, 200 and 192.168.1.025. But I don't have that subnet network 192.168.1.128, but R2 has. You can see R2 has 192.168.1.128. This is the subnetted network, but this router only has 192.168.1.0. It means we need to create a route. We need to set up a manual route that is known as static route. So S stands for static. It means I am going to add that route manually. So how to add? So go to configure terminal and I'm going to type IP route. And what is the IP address? 192.168.1.28. Why I'm giving 192.168.1.128? Because that is my network ID. And if you don't know what is the network ID, just check the another router and you will find that network ID here. So this is my network ID. The first IP address of any subnet is known as network ID. Always remember when we give static route, we always give network IDs in most of the scenarios. This is not a language. This is the just simple commands. This is not a language, NAB. So IP route 192.168.1.128. I am going to type here 255.255.255.128. Now router 1 is going to this network with the help of router 2, right? Route If router 1 wants to communicate with this network, router is going from 200.1.2. Means router 1 wants to go to 192.168.1.128 and this is the subnet mask. Here I have to add what? Next hop. So first we always type network ID. Here I always type subnet mask. And here always I give next hop. Next hop means the neighbor router. Okay, the neighbor router is my next hop IP address. So my neighbor router IP is, I'm getting this route from where? I'm getting this IP or route from router 2. So that is 192.168.1.128, 255.255.255.128, 200.1.1.2. So in router 2 also, so when we have static route, now my computer is going to send information to this machine. And when this machine is replying back, now router 2 needs this IP address. So now router 2 does not have any entry. So router 2 also router 2 should also know this network, that is 192.168.1.0. So on router 2, I'm going to type IP address of router 1. So what is the IP here? 192.168.1.0. So on router 2, I need to create a static route, IP route 192.168.1.0, 255.255.255.128, and my IP address, neighbor IP address is 1. So these are the two static routes you need to create on R1 and R2. And let's test if we are getting the ping. Yes, we got the ping from R2. But we are not pinging Linux machine right now because we have not configured it. So let's give the IP control panel or maybe network. Yeah, from here we can give IP. So IP address is 192.168.1.201 something. Okay, and my gateway is 200, I think, and apply. I think 201, yes. So let's test if my machine is pinging 192.168.201. So 192.168.21201. Yeah, so we got the ping, guys. Can you see that my Linux machine is connected? Can you see now? So you can give the command on Linux with the terminal also, but that is a little bit complex with if config command. Okay. So here you can see I have given here inet address 192.168.1.201. Okay. So now my Windows machine is pinging my Linux machine. And you can see both the networks are in different locations maybe, or you can see that both different networks are connected. So I'll type here static routes. Maybe you are getting confused how to give. Let me repeat it. On R1, R1 has only 192.168 1.0 network and 200. So it means router does not have 192. Yeah. So router does not have 192.168 1.128 subnet mask, and the next hop IP means router to IP address. So this is the route on R1 I have to give. Okay. And on R2, I need to create the reverse static route. So reverse static route means instead of 128, because 128 is his own directly network, here I have to give 200.1.1. So router 1 will create a static route for this network and router 2 will create a static route for this network. This is I have done. Okay, just understand my why I have added static route, because when traffic is going from this computer, router 2 is not forwarding the packet to 192.168 this 1.20, because we don't have information of this 192.168.1.200 network on R1. So we have created, and what is the network ID of this network? 192.168.1.128. 128. So this is the reason we have added here 192.168 1.128. You can see here. And if it's little bit complex to you, so don't do subnetting, just learn. And let me change the IP address if you are getting confused. Okay, so you can change the IP over here also. Like if I can give here 2.1. Okay, so you can change IP 2.1 here. Okay, so you can do like that also, but I'll keep this so you can do it on yourself. Okay, so this lab is already in your system. I'm not saving or anything here. So you have to complete this lab, and I have already shared the notes with you. Okay, and before I stop these devices, let me show you how to configure DHCP. So what is DHCP? When my computer gets IP addresses automatically, and let's understand what is DHCP. Okay. So let's understand what is DHCP. Okay. So DHCP stands for Dynamic Host configuration protocol. So when you want that your router should give IP address to your computers automatically. So DHCP is a protocol which assigns IP addresses automatically. Okay. So in DHCP, what happens? So suppose this is my computer and this is a DHCP client. Okay. And your server could be your Windows server, or maybe you can have a router as a your DHCP server. So it depends on company to company. Some configure on servers and some configure DHCP pool on router also. Okay, so if you have a very big company, you can configure a DHCP pool in a server, and when you are a small medium scale enterprise, you can configure on a router also. And in our home connections, we use router as a DHCP server. So these are my servers. Okay, so they will work as a DHCP server, both the devices, and this will be my DHCP client. So there is a concept known as DORA. What is DORA? So first I'm going to send a discover, and so client sends discover. So what does discover means? Discover means to find the DHCP server. To find the DHCP server, I'm sending, or clients is the whole, like maybe you have 100 computers in your networks, all are going to send a discover packet to search to find DHCP server. Okay. And now server will, or router will check its DHCP pool table. There is a table known as a DHCP pool table where all the IP addresses are written, and it will be like that. All IPs are free or assigned. So whatever IPs are free means they are not used anywhere. It is going to send one free IP which is not allocated to client with the offer message. Offer message of any IP. Maybe this computer has 192.168.1.2. Now offer message is to allocate. Instead of allocate, you can see that. So server is going to offer IP address from the pool. What does pool means? Pool means like a group. Okay. Maybe it has a pool of around 250 IPs. So one IP address is going to allocate to this client. So now if everything is okay, then client is send a request packet. Okay, give me this IP. So here I'm just showing, I'm just offering, are you okay with this IP 1.2? And request means yes, I am okay with this IP. Please give me this IP. So in which packet we get all IP configuration? In the last packet, acknowledgement. Send me IP configuration. So request packet is to get the IP configuration, and in acknowledgement you get the, here is the configuration. Here is the configuration. So in acknowledgement packet, the server will send the IP configuration details. Yes, offer is unicast. Discover is broadcast packet. Offer is unicast packet. Okay. So again, I'll repeat. So client is going to send a discover packet to find. Suppose I am a server, okay, and you all guys are clients. So first you are going to send a discover packet to me, and I'm going to give IP addresses from this pool. So this is DHCP table. So I'm going to send you all one IP address. So all you have different IP address. And if you like the IP address and all, so you will request me, send me the IP configuration, and with the acknowledgement packet, I'm going to send all the details in acknowledgement packet. See, acknowledgement request will be unicast, and rest you can check with the some packet capturing tool like Wireshark and all. So I'll add one screenshot in your notes so that you will understand DHCP. Yeah, so you can see here. So this so DHCP discover is a broadcast packet according to this image, and then we get offer as a unicast. Again, computer does not have any IP address, right? In this packet also we don't have any IP. So still we are going to send the request to the as a broadcast to the server, because it will have DHCP server IP and it is going to send unicast. Okay. So your discover messages from client is always broadcast and messages from server is unicast. Okay. So you want me to configure DHCP server in our practical? No. Then why you are here, man? Somebody is saying no. You can take leave. Yeah, I'm going to configure DHCP server. Okay, so I'm going to configure a DHCP server in this R1 so that my window machine will get IP address automatically. Adil, I'll explain ending process. Trust me, I'm going to explain. Okay, so let me configure DHCP on it. So on R1, I'm going to configure a DHCP pool. This is not the last session. We will have last session tomorrow. So DHCP pool, how to configure? It's very simple. Go to R1 and in the enable configure terminal, and I'm going to type here IP DHCP pool, and we can write any name here. So suppose LAN network. Okay. So you can give your name also here. Okay. So we will create a pool IP DHCP pool LAN network or anything, any name. And then we will type the IP address of a router, default router. Who is the router? Router IP would be 192.168.1.1. Okay. And for which network we need to give IP? 192.168.1.0, 255.255.255.128. Here we are assigning the pool. The IP addresses from this pool will be assigned to your machines. So here I'm making a pool. I'm giving here default router 192.168.1.1. This is my gateway for all my devices. And what is the pool? Pool is give IP addresses from this pool. It means the block of this IP 1.0 to 1.127 where we have done subnetting. So we are going to assign IP addresses from here. Source MAC would be the computer MAC address, right? So let's see if my window machine will get the IP addresses automatically or not. So how to choose a DHCP? Because we have given static IP, we need to change the properties with the DHCP. And by default, all your machines have this options enabled. Obtain an IP address automatically. So let's check if the computer will get any DHCP IP. Status, detail. Yes, we got the IP, guys. DHCP is enabled and we got the IP address 192.168.1.2. The same IP which we have given in static. Okay. And in R1, let's check show IP DHCP binding. So this is the pool. Okay. So this is the pool. How to check the pool? Show IP DHCP binding. So what is the command? Show IP DHCP binding to check the pool. So you can see on 192.168.1.2 I have given IP addresses. IP address 1.2 and the lease expiry means this IP address will be given till March 2, 2002. Maybe the router have incorrect time right now. Yeah, it's these routers are like 18 years old maybe. No, that actually that clock is not set properly. So you can see in my router it's March 1 and here I'm giving IP till March 02. It means 24-hour lease time. Lease time means this IP address will be allocated to this machine. This is the hardware or the MAC address kind of thing of that device. So if your computer, if you turn off this device and you turn on the device in 1 hour, 2 hour or 3 hour, the device will get the same IP address. But if you turn on this device maybe after 2 days, might be there is a chance you will get another IP from the pool. Okay, clear? Okay, this is how you configure DHCP. Okay. So all of right now in my practical, I have used only one PC. So you can use multiple PCs over here and so that you can connect and check if computer is getting the IP. Yeah, Linux also same like that. You need to just choose the DHCP service. We can configure on R2 also. Let's configure on R2 for better practice. On R2, my default router would be 1.200 router IP and pool would be 1.128. This would be the network ID. So on R2, I have to configure like this. So enable configure. So you can use the same name on another router because this is locally significant. Means if I'm creating a pool here, so it is not related to R1. So you can use the same pool name here also. It should not be different. So it's your call. You want to use the same name or you want to use the different name. Okay, and on Linux machine, we need to use this use DHCP apply. So you can see here I got the IP address 1.201. Can you see that? The same config I got in Linux also. Kaleem, actually we have made our router as a DHCP server. We have made this router as a DHCP server. You don't need a DHCP actually server. So this is just a terminology. We can create a DHCP server in our router. This is what we have done. So most of the companies are using this terminology. Just take an example at your home broadband connection. Do you have any server at your home to get the IP address? No, right? So you have your DHCP pool inside your router. Okay. So the same thing we are doing on this Cisco router. So you can configure on any company or any vendor device also like Juniper, HP, Aruba, any company. So just you need to figure out what are the commands. Okay. See, these are network fundamentals, but I just don't want to stick with the theoretical knowledge. I'm just giving you that practical knowledge. At least you will get an idea if you learn networking, if you go ahead with CCNA, CCNP, what exactly and how you will understand. Because we have limited hours here, okay? But you need to practice more and more, okay? You can't be expert in 5 days, right? So this is just you need to understand how things work, and if you are going to proceed with further advanced things, so you will be learning in this way. Okay. Yeah, so notes link I am going to share, don't worry. Here you go. Okay. So uh so telnet is remaining. So let's do telnet tomorrow. Okay.
Hi, you are watching the recording from one of our live session. Hit like, share, and subscribe for more future updates.
So hi everyone, this is day 5 for network fundamentals. So let's see what we have done in those 4 days. So all the links are updated. If you don't have this link, I'm going to share this link again, and you can bookmark this link, or yeah, so just bookmark this link. More, I don't think the link will be changed, so it's better you can copy this content, or when you open this link, you can click on duplicate to add these notes into your Notion account. Okay, so these are the details we have mentioned that I'm starting one CCNA batch from 11th Jan, CCNP from 9th. And if you want any English batches also, there is the like we have mentioned the details, and you can use this coupon code to join any of the course before 31st. Okay. And already lab access is going to expire on 31st December. So whatever I had taught, so just go through it and just try to learn. Okay. So whenever you have any doubt, there is a link, Ask Doubts. You can always refer this website, Ask Doubts. So you can ask any doubts you have. You can see I can't see any doubt in this post. Maybe you guys don't have, or you don't have time to ask. So rest all basic things what we have covered is mentioned. So we have done few labs here, like when we connected one router with two different networks. Yeah. Kaleem, you can see whenever you open this link, right? So there is a option called duplicate. So just make a Notion account so that you can copy this all information. See, you can see here duplicate. Okay. So just duplicate, log in with your Gmail ID, and it will be always in your ID because you have made a duplicate of this notes. Okay. So on this topology, we have configured static routing. What is static routing? Means you need to inform your routers about the destination network. That is static routing. Okay. So that we have done. So today I'm going to explain you this telnet. So how we configure telnet, and I'm going to show you or discuss about futuristic technologies also. Okay, like AWS, where the world is moving to, what exactly you have to learn in 2021. So few things I have discussed, but I'll discuss more today. Okay. Yeah. So what is telnet? What is telnet? So telnet is a protocol to remotely access the network devices. Okay, so this telnet works on port number 23, TCP 23. Okay, port number 23, and this is unsecure. So telnet is considered as unsecure. So we have another protocol, that is SSH, that is secure shell, that also used for to remotely access the network devices securely. So you can just add securely. Okay, cool. Secure shell. Okay, and this also uses SSH, also uses telnet, and the port number is 22. So port number for SSH is TCP 22. If you don't know the port numbers, let me write here all the ports which I know. Port numbers. So what are port numbers? So that is the identification of the service. Okay, so we have 121023. So that range is known as well-known ports. Well-known ports. Like all your TCP, UDP ports comes under this category. So we have registered ports. If you have your own service or any application, you can buy these ports number from IANA or from registered numbers. Okay, from 49152 to 65535. So these ports are known as dynamic ports. We are discussing what is telnet, SSH, and I'm sharing what is port number. So port numbers are like to uniquely identify the service. To uniquely identify the service or application. Okay, so we use port numbers. So our first category is well-known ports, second category is registered ports, and third category is dynamic ports. So these are the range. So like all your famous protocols like HTTP, HTTPS, SMTP, S, SNMP, all protocols which are popular comes under this well-known port category. It means these are well known. Registered ports means if anybody is making any applications, like somebody made any Zoom application, or somebody made some another software, or maybe some different kind of service like Cisco WebEx or anything, right? So if you made any application which works on port number, then that application needs to register that port number from the Internet Corporation number or maybe INA. Okay, Darshan, well known means the popular ports are known as well known ports. Registered ports where any company make any software and wants to buy the port number to run that service. Okay, and dynamic ports are like generated by PC. So whenever your computer go to google.com, facebook.com, so all computers actually add the port number. Okay, so whenever any computer go to any particular destination, it adds the port number, IP address, MAC address, right? All those things are added. Yeah, so dynamic ports means the ports which are automatically generated by PC, so that port will be added into the so as a source port category. Okay, so the dynamic ports are dynamically generated, means it's generated by PC. Okay, so well-known ports which are popular, and registered port numbers when any service wants to get registered. Okay, yeah. So let's configure a telnet or SSH. Just hold on, let me, guys, in the more option there is an option called higher hide, sorry. So you can hide the cameras, or if somebody is irritating you, maybe. Okay. Well, okay. So telnet. So how to configure a telnet or SSH in a lab? Okay. So I'm going to show you. Okay. So this lab, router lab, or maybe this static routing lab. So you can use any of this lab. So I'll use this router lab. Maybe the configuration is gone from this device. I don't remember that I have saved the configuration or not. So I'm going to turn on my Windows PC also so that I can show you how to telnet or how to do SSH. Okay. So just let me check if my device is on. I don't know why it's taking time today. Yeah, Kalim, telnet is not secure. SSH is. It usually okay. So I need to say no. Yeah. So you can see the config, guys. Right. So how to configure telnet on this device? So I'm going to say enable on this router and going inside configure terminal. Okay. So you can see this topology that I want to access the router from this device. I don't have to go every time on a router to access the device. So I want to accessly or I want to access this router remotely. Remotely means you want to access any router from outer city, or maybe you want to access US router from India. So if you can ping your router, so let me check if I have given IP address on this device or not. Show IP interface brief. So router doesn't have any IP address right now. So let me give on FS01, FS01 IP address 192.168.1.1. Let's go with the by default subnet mask and done. So I have configured this router, and inside the PC I'm going to give any IP, maybe like 192.168.1.11. Yeah, so you can see I have already given IP address here. So that config is almost there in the PC. So let me check if I can access my gateway. So you can see I can access my gateway. So what I have to do, I need to access the device from here with this application called Putty. So every time you don't have to go in a server room or somewhere where your router is placed, right? So you don't have to go every time at that same location. So instead of going in the server rooms and all, so you can directly configure the router so that you can access the router from remotely locations. Okay. So after giving IP address, I'm going inside configure terminal and I'm going to type line VTY. So this VTY means virtual terminal lines. So you can see how many VTY lines I can create. So just remember, one line means how many users you want to access or how many users can access this router. So tell me to how many users we will give this access. 0 to 4, it means 5 users. 0 to 9, because it starts from 0. 0 to 9, it means 10 people or 10 engineers can access this router device. Or if you give a 0 to 903, it means that is the maximum limit of this router. So 904 person can access that device. Okay, clear? Hello everyone, I'm audible. Okay, so how many users we want to give access? So let me give 0 to 4. So that is for 5 user. So why? So we will write password is something like I'll write password is ABC, and this password is for login. Okay, so once you set up this telnet, these are the only three commands to configure telnet. So what are the commands? So just go inside your router with enable command, right? So configure terminal. Okay, so config terminal. So line VTY 0 to 4, password Cisco, and that is for login. Okay, so VTY04, password ABC, login. So let me go inside my device. So here I'm going to type my router IP, and that is 192.168.1.1. Choose the telnet option and click on open. So you can see it is asking me for the username, sorry, password. The password I have given is ABC. So now I am inside my router. So let me give enable, but it is giving me one prompt, no password set. Means we are not able to do this. We can't enable the router with the PC. Why? Why we can't enable from PC? Because when you configure this line VTY, so there is a command enable password, or you can give any password like enable password ABC or something. So I am giving here enable password Cisco. So that is the recommended password, so that if you want to access the device. So you can see when we set password, then only you can do telnet. If you don't give this command enable password, you can't log in. So that is another mandatory thing. You need to give that IP, or sorry, command enable password. So there is one alternate command, enable secret, or whatever the password you want to use. Okay, so in both the commands, enable secret is always the winner. Okay, enable secret means little bit more encrypted, and password means normal one. Okay, so you have seen that I'm doing configurations from this device only. Okay, so now what is SSH? See, SSH is you can learn the this basic configuration. SSH is little secure, but you will understand all that configs in maybe further advanced things. So SSH, just remember right now it's encrypted in comparison to telnet. Okay, telnet is not secure because the data is not going to secure with any layer or something. So it's clear text. So clear text means everybody, the data is going between any device. So you can just check and what's the data is going on. Means that is clear text. This is the reason it's not secure. Yeah, no encryption. Correct. But if I'm going on this PC and I'm going to choose this instead of telnet, I'm going to do SSH to this device. Let's see. The same IP address I'm going to add here, but instead of telnet, I'm going to choose SSH and open it. So you can see there is a network error for this SSH. Okay, so how to configure SSH? So obviously you will not understand the command because you have not done enough practice to understand it. But I am just showing you. So whenever you configure SSH, you need to give the device name first. So second thing is that you need to set up a domain name. Okay, so why we are giving host name is okay, but why we are giving domain name? So domain name plus your device name both actually makes host name plus domain name. From these two things, the device is going to create the encryption keys. So host name and domain name is important. So now the important thing here, host name R1 IP domain name nwkings.com. So I need to give one command crypto key generate RSA. So it is asking me how much encryption I want. So if I want to secure it by default, that is 512. So you can see I have, so in SSH, what happens? So in SSH, so in SSH also, so so in SSH, what we do? Yes, in SSH, what we do? Host name ABC. So next thing is IP domain name nwkings.com. Hostname ABC domain name, and then we have to give one command crypto key generate RSA and just enter the modulus and all whatever is done, right? So once done, you need to create a username for your team members. From these IDs they can access the devices. So suppose the username is ABC and password is ABC. That's it. So you can create enough email IDs also. So once done, so obviously you need to go inside line VTY 0 to 4 and you need to say password instead of saying something about password. So you can write here transport input SSH. So it means this line VTY means virtual terminal lines like in telnet, but in this line VTY 0 to 4 only you are allowing telnet SSH instead of telnet. It means if you want you want to access the device with the SSH, telnet, and other skills also. So you can add a telnet here also. Means the device will enable SSH also, telnet also, right? So transport input SSH, telnet. So let's check now in this PC. So how to access? So 192.168.1.1. So instead of telnet, I'm choosing SSH and open it. So the device is giving me one error. This SSH protocol version supports only version 1 or 2. So we need to enable the IP SSH. Okay, so guys, we need to create again crypto key, because if you want to secure, you need more version 2. So when you give crypto key generate RSA below 768, it will work like version 1. And this is, so do you really want to? Yes. So how many bits? I will write a 1024. So when you type 1024 encryption, then only you can secure. So once this done, so let me check now. So you can see here, it is asking me for multiple prompts. And once we are here, so we have, means the device is asking for the username and password. So the device name, what we have created here, username is ABC. So ABC. Okay, just hold on. Don't worry, I'll write this config for you. So I'm just checking why this device. So let's do the telnet first, if telnet is working. Yeah, so here we can do telnet, but whenever we do SSH, it actually drops. So we have created a username. Let me create one another name also. Yeah. Thanks. Yeah, guys, one command is missing. Thanks. 0 to 4, there is a command called login local. So whenever you make username passwords, and so what will happen? What are the commands? So after crypto key generate RSA, so just use 1024. How many bits you can encrypt? So whatever, if the number is big, it means it will secure it more. And after this, you can create username, suppose ABC, and password ABC, and inside your line VTY 0 to 4 or something, you need to give login local. That is the only command. Okay, so it will work definitely. ABC, ABC. Yeah, so you can see now I'm inside in router now. So this connection or whatever the information is going on, it's encrypted. Nobody can see it. So whenever we send any data with the help of telnet and all, so it actually does not secure the data. So SSH is better in comparison to telnet. Okay, so that is a telnet SSH. And just you need to understand about telnet is very simple to use. Just go inside these three commands only. Line VTY 0 to 4, password Cisco login. That's it. And here in SSH, so you need to create one host name and domain name. So because host name and domain name both actually makes crypto key. So crypto key is like to secure the system we are generating our crypto key, and that key size is 1024 bits. So 1024 bits, create a username password and login VTY. So just add here transport input SSH. And if you want telnet to import also, if you want SSH or telnet to use both at a time, so you need to mention telnet or input SSH only, or transport input telnet only. Show key chain, or maybe you can check with the show RSA, show key RSA something. Okay, so means in these fundamentals we have not covered the fundamentals with only theory knowledge. And these sessions are obviously might be you are not confident enough to configure these telnet SSH because you have not done enough practice. So in these a few days, 3 to 4 days, right? So might be you have attended all my sessions, and if you understand it properly, you are doing labs properly, it means you are very ready for the next things which will come up, right? And still the guys who are planning or learning these 5 videos, doing some labs, so it's better to learn so that whenever you join anything further, so actually you at least know few things so that you will understand or you can ask about the questions. Okay. Yeah, so this is about telnet and SSH. So yesterday one question was remaining, sir, what is ending process? Okay, so I'll explain what is ending process. So our topic is ending process. What is this ending process? So whenever any computer wants to go to another computer, so computer will actually calculate its binary value. So what would be the binary for whole IP? Might be 11000000 like that. Just hold on. Yeah. So 110000, and then for 168 101 010 like that. Okay, so you need to calculate all zero ones, and for 11 might be you have 0000 128 64 32 16 8. Yeah, so this is a binary for 1.11. So now computer, whenever you type any ping or any different IP, so computer is going to check its binary value also, and most of the values you can see up to this network, the values are same. But you have given here slash 24, means slash 24 or subnet mask of 255. How many 255 by default? 3 times 255. So it means three networks should be matched, and whenever computer actually calculates the binary of both the machines, right? So for two, the binary would be 00000010. So you can see in the third octet, you are getting a difference. Yes or no? Right? You are getting a difference. So in three octets, my values are not matching. It means this another device is not in my network. Can you see that first portion is matched, second is matched, but third is not matched? So this is known as like ending process, where the system calculates the information. So also how they calculate the network ID, whenever this is source, this is destination, and there is a ending process. 1 1 is 1. Whenever we have 1 0, that is 0. 0 1 is considered as 0, and 0 0 also 0. So let's calculate 1 1 1 1 1 1 and rest all zeros. So this is I'm doing ending. Okay, so these are, if you have gone through to digital electronics, and gates, NAND gates, maybe in your college. If not, just understand. So there is a in electronics, in ending process, 1 1 is known as 1, 1 0 is always 0, 0 1 0 0 0 0. Okay, so 1 1 1 0 1 0 1 0. So 0 0 0 0, all zeros, right? So here also you don't have to calculate. So this is the ending. So ending means you can see that both the information, means this ID and the third octet of these source and destination is different. So when we have this ending processes, the values are different in both the things. So it means they are not in my network. So this is ending process. I hope it's clear. Let's take an example here. If we have both the systems in same network. Okay, so I have another PC here. Might be this IP is 1 dot mm, 10. Okay, 1 dot 10. So 192 168 1. For 1, the binary will value here also would be 1. So you can calculate the ending process of all three: source, destination, and the ending value is also same. It means they are in same network. That is ending process. If my ending values, which are 11000 like that, if that is not same, it means the device is not in my network. Clear, guys? Again, that ending process and all, it's means when you go and attend in interviews, that actually ask sometimes in good interviews, tell me what is ending process and all. Like I have given one interview for one US company few years back. So that the company was hiring for like HCL US. Okay, and there is one guy that was not from India, might be from somewhere else. Okay, that person asked somebody ending process. So that, okay, so ending process even asked to expert level engineers also. Okay, nobody is acknowledging today, and today is last day, but still you are not interactive. Hmm. Okay, so this is ending process. Okay. So what I'll do, I'll go on LinkedIn. Okay. So I'll show you some strategies. Uh, let's go to jobs because everybody is learning to either boost their career or either to improve their technical skills or maybe looking for a job change. Okay. So let's find something here interesting. So let's write here maybe CCNP or something. Okay. So you can see there is a opening in Google. So that company is actually looking for a lot many things. Yeah. So you can see here bachelor degree in master in computer science, experts with compute infrastructure and networking concepts including routing, VPN, load balancer, and firewall. Means Google is also asking. So this is a Google, right? My 8 connections work in Google. It is showing me here. Okay, and I can check who are the connections. I can always interact with me with them. Yeah, so this person actually I know him very closely. He's my 1 year old junior, and we used to play Counter Strike in our college. So I can easily interact with him and ask about this opening, or I can take a reference. So you can apply job, but always make sure build connections. LinkedIn is not Facebook, guys. You are not here to just chit chat, right? LinkedIn is all about making connections, right? And yes. So always appreciate other ones in LinkedIn. Whenever anybody do certification, you need to post, yeah, very good. So like this person, this is my student, right? He has tagged Cisco DM VPN. So he has configured a DM VPN technology and tagged me into this lab. So just last weekend I have, so I will always appreciate good lab like this. Okay, so whenever you appreciate someone on LinkedIn or something, right? So actually it builds connection. So that is first secret to get a job. So you must be wondering how it's possible. So I'll show you one trick now. I told you there is a job opening in Google, and if your target is to go Google or Apple or any big company, how you are going to do that? Okay, but make sure those companies have that job. Suppose you are applying for a job in, suppose maybe in Samsung, and might be Samsung is not looking for network engineers, right? So what I'll do, I'm going to type here. Let's check. I want to apply a job in Samsung, suppose, or maybe any. Let's go with the Google. So what I'll do, I'll click on Google company. Okay. So I'll go with people. So there are a lot of guys who work for Google, right? So you can see here. So here I can search CCNP or whatever positions. So you can see all these guys are from Google and they are CCNP, CCIE, and these type of connections. So I will always connect and with a note, hi, like you can write very good line about Pradeep something. I checked your profile and seems like you have very good knowledge and looking forward to connect with you, like that. Or maybe you can just send it, right? So when you type, and when they become your friends, when they all become your friends, what next? You need to go on their profile and you need to check the activity of that person, where that person is actually posting. We need to spy that person. You want to work in Google, yes or no, right? So now you can see what exactly he is doing, right? So Pradeep Karole like this. Okay, so you can just learn the behavior. Like Google, Facebook, all companies are learning behavior. So you need to learn behavior of the experts or those who actually work for any good companies, right? So that is my strategy that worked for me. And I can easily my last I got selected in AWS Ireland. Okay, but I have not joined because to run my company, to impart knowledge to the world. I'm running a successful company right now with almost 35 employees. I have three more startups which are running as a software development company. I'm running a digital marketing company also. And we have a very good YouTube channel and good company. You already, most of you know Networkings. Okay. So this is the reason I have not joined, but this is the trick. Nobody is going to explain, okay, or these things with you. So this is how, so I directly helped you, and that how you make connection with the guys who are actually outside India, or maybe those who actually work for Google, Facebook, Apple. So just connect with them and keep checking their profiles. Okay, you can make Excel sheet also. Don't disclose that sheets with anyone. Just take the URLs in that sheet and paste it. So whenever you have time, just keep looking at the profile and always try to build relation with that person. Okay, so this is how you go ahead with the, see, just tell me honestly, if I am not working and you are working somewhere and you feel like I'm very good, or might be I'm doing a lot of labs, I'm posting daily, right? So everybody checks the profile, right? Most of the guys who are working professional, they keep checking the profile. And whenever you post your achievements, whenever you post your labs, right, or maybe you can post your articles also, the person, you need to make sure that the person will be pampered enough so that you will build connection, or the person will become your friend to always, whenever there is an opening in his team, he is going to call you. Hi Atul, can you share your resume, I have one opening. Okay, or maybe you build that connection so that you at least becomes eligible to ask, right? Suppose what happens, tell me honestly, you are walking on a road and somebody comes to you and sell iPhone to you directly, even it is 40,000 less amount, would you buy? Tell me honestly. If you don't, we are humans and we actually believe in trust. We actually check the authenticity and all other things, right? So whenever you have good connection, if your friend meet you on walking road and say that I am in need of money, actually I am selling this iPhone, just bought yesterday, and I bought in 1 lakh, you can buy it in 50,000. So maybe you will go ahead and it will be help for him also, or maybe he needs money, or maybe you like the phone, right? So maybe you will buy because you know that person. So the same way it goes in the LinkedIn also. So whenever you apply or you make a connection, you don't ask in the first time that do you have any job opportunity. I get a lot of messages in LinkedIn. Okay, sir, do you have any opportunity? I don't know that person. I don't know how much technical he is, right? Why I'm going to refer that person to someone? I don't want to see, if I'm going to refer the I'll break my relations also, because if I'm giving any non-technical guy or the person doesn't have skill, it will be wastage of my reference also, right? Are you getting now what I'm trying to say? Nobody gives bad references. So that is exactly what I have learned so far in these 10, 11 years. So I hope that will help you also. Okay, so I don't know how many connections I have, like, but maybe I think how to check. I think here, yeah. So maybe I have 6,000 connections almost, right? And it's not that and but I have added all connections related to my profession. I don't have any single person means maybe few of them, but most of them out of 6,000, like my 5,000 connections are those who are from this network world. Okay. So build connections with only guys, those who actually work in these networking. So you can see all three profiles related to networking. I'm going to accept these connections, or maybe I'm going to send the request. Okay, but if anybody is not related to my profile, I don't accept. Or maybe it's not relevant for my profile, because sometimes HR also connects with you. So please accept that if they are genuine. But no need to add those guys who are related to marketing. And there is a new trend going on in LinkedIn. This what we call network marketing. People message us, are you looking for anything part time? Would you please help us in selling MWay products? Man, that is also the new things going on. Okay, and there is another type of guys who actually sell dumps directly in LinkedIn. Are you looking for certifications like that? Okay, do you want to buy or do you want to pass in one go? I don't know, like you get these type of messages or not, because I usually get those. Okay, so that is the trick I have shared, and few other tricks I have, right? But also I can only say that we have limited time. Maybe we will meet in a batch, or maybe you can ask me sometimes in LinkedIn. But yes, I usually don't reply if the message is not relevant. Okay, or maybe if somebody is only asking me how are you, so it's better you just ask in one go. If you have any good question related to career, you can always ask me in LinkedIn. Okay, I'll always try to help. Okay, so these are the batches, guys. If anybody is interested in CCNA, so directly come and join my batch from 11th Jan. Okay, so timing would be 8:30 p.m. to 11 p.m. CCNP, if you are enough, no, if you have enough knowledge, if you know about OSI model, basic CCNA, or maybe few years back you have done CCNA, so you can directly come to my CCNP batch. Okay, if you are a fresher looking for a job, you just want job right now within 1 or 2 months, 3 months maximum, you don't want to waste a time getting into IT industry, just go with this batch phase 1. This is specially designed for the freshers. Okay, and if you don't understand Hindi and all, we have English batches also. You can refer to this link. So there is a coupon code new 2021. Okay, so try till 31st December, and if this works fine, then it's better. Okay, so any questions you have, you can ask me in chat. I'll be for next 5-10 minutes. Kaleem, sir, I am student doing my bachelor's in computer science. I am final. I have to select between programming and networking. Kaleem, which actually motivates you, right? So in both the fields there are high salaries. If you love networking and really looking forward to become a expert, right, definitely programming has a lot of competition, networking has less competition, networking has less jobs also in regards to programming. It's you. Yeah, so if you are more interested in networking, you are always welcome, go ahead. If you are okay, if you are not, good in programming or you don't like programming. Azab, I am not from fee department. You can always check the links because when you discuss with the team, they can also share all details with you. I don't have VMware right now, and VMware it's better to learn like cloud technologies also. MCSA is retired by Microsoft, but we are not teaching to make you certified only. We are actually training so that you have more skills. So my views on emerging technologies, like you can start see the new technologies are you should learn if you have good knowledge of CCNA, CCNP. See, first of all, again, that day I have explained that you need to create a base. So the base comes from CCNA, CCNP, these sets. And firewall nowadays, everybody asking for firewall knowledge. I showed you, even Google was asking for firewall, right? Even the cloud engineer profiles have firewall, VPN, these type of knowledge. So you should learn these if you really want to become a good engineer, network engineer. So this is my first step. After that, there is a course SD-WAN. You can learn some Python for a DevNet, what we call DevNet, development and network operations. Okay. And someday you can crack CCIE also. You can learn futuristic more technologies also. Like, and then after that you can go. So you don't have to learn CCIE, or you can so it's better you go with the cloud and other things as well, like these ones, right? So it depends on your career also. Where are you working right now? If you work for Airtel, if you work for any service provider, if you work for any tag profile, so still you have to learn new things which are not related to your profile, because might be you are working for a company right now, but maybe the next company is looking for something else, right? So keep updating yourself, keep learning, and just make a target to at least cover 2 3 technologies in a year. Don't be like an mediocre and just learn CCNA, CCNP in 10 years, right? Just boost. Nowadays, freshers are doing CCNA, CCNP, and firewalls, right? So you have to keep update yourself so that you will help other companies to grow also, because from market perspective you are like a product. If you have very good knowledge, if you know multiple technologies, then boom, definitely you will be going to crack the interview, and within 5 to 10 seconds your profile gets selected. Whenever you apply for any job, suppose I'm going to apply for the same position in Google, Google is going to check my profile. The recruiter of Google, recruiter is going to only check my profile hardly for 5 to 7 seconds only, because they actually skim it, right? They only just get the overview. Okay, this person have done this. Okay, let's go further. Okay, this person have that much. So once you have that summary of your profile is good, then only they are going to open it. They are going to refer it to manager or the team. So your profile seems to be very good when they are actually searching it. Okay. Okay, guys. Thank you all.